Welcome back, everyone. This is Michael Gibbs, and this is day 2 of the free Go Cloud Careers AWS Certified Solutions Architect Associate 2024 Bootcamp. And this is going to help prepare you for the AWS Solution Architect certification. And this is an AWS full course tutorial. If you missed day 1, that's okay. You can still see day 1 of this boot camp on our channel. Our team will provide the link. You can go back and see it after today, and you'll be just fine. And in this free AWS certification training course, we're really preparing you for the AWS Solution Architect Associate slash SAA-CO3 exam. So we're going to have some fun here. At least I had some fun yesterday. We got to have a big discussion yesterday. And continuing with our discussion, we're going to stick with the networking, at least for the beginning of today. I want to get the harder stuff out of the way first. And that way, the rest of it becomes simple because everything really in cloud computing is networking. I mean, all of it. It's all based upon the network. So if the network doesn't work, nothing works. In fact, the first clouds that I worked on back in 91, and I'm sorry, 93 and 96 and 99, they were all network-based clouds. So lots of networking things here that are super important. So I hope you enjoy this AWS certification free course because we really want to help you. So we'll begin in about 2 minutes or so. I know everybody typically comes in a little bit late. I run these things all the time. So if you want to invite a friend or know anybody that's interested, send a tweet, send an email, invite some friends. If you just got here today, we're going to be doing 3 hours of AWS Solutions Architect Associate training every day this week and every day next week. And the week after that, our team will invite some people to some hands-on live demos as well and answer any questions to try to help you even more in this free training session. So let me tell you about some other 3 free things we have to help you. Because we want to really make sure you understand the technology, what it is, where it's used, how the technology works. We want to make sure that we spend all 30 hours covering the technology. After interviewing 6,000 people, it's very easy for me to find someone that knows how to configure, but doesn't know why they're configuring it, what they're configuring, or the need for it. So it's still important if you want to be a cloud engineer or a DevOps engineer or somebody else that's got a hands-on position to get your hands dirty and get hands-on. So please download the completely free AWS lab demonstration videos. There's over 40 of them there. Good labs for you to do, get some hands-on experience, and I encourage you to do so. My team will pop them up there, and they are completely free. So go along and do those labs. In addition to that, we also have a free certifications guide, say, what kind of certification should you do to build your career? They're completely free. It's a free ebook our team wrote. And the reason we wrote it is so many times we see people that come to us with a ton of certifications and they have got a goal career, say being a cloud architect, and their certifications make them look like they're not. So here's a certification guide to tell you what you should do that'll help augment your skills and build your profile and make people want to look at you because they're going to see you as a leader in your field, a specialist in your field, as opposed to, say, someone that's confused as who what they want to be. If you needed surgery and you went to a doctor and it said dog walker, gymnast, martial artist, flight attendant, and doctor, you wouldn't be impressed. But if you saw a great medical school and fancy degrees and residencies and fellowships and years of expertise, you'd want that person. So I want to teach you how to be great, and that's free in the certifications ebook. So go get it. So the last part of starting out today is me knowing that you are awake, alert, and oriented in this free AWS certification training. So please give me a hashtag AWS Solutions Architect Associate or a hashtag SAA-CO3. And we'll begin the course as soon as I see that coming onto the screen, because I want to know that you're here and you're awake and you are ready to go. Because I know I'm ready to go. I see people are coming from all over. I see people from Philadelphia, which is where I grew up. I see South Africa. I see Sacramento. I see Brazil. I love this. I see people in Mexico, spent lots of time in Mexico. It's a beautiful, beautiful place. I see people all over the world. So welcome, welcome. And if you're going to enjoy our content today, please hit that like button. And if you're enjoying what you're learning, hit the subscribe button as well, and then hit the bell to be notified of new videos, because we've got lots of videos to help out with your cloud architect career, your AWS Solutions Architect career, your Enterprise Architect career, your Artificial Intelligence Architect career, and many other architecture careers. We train lots of security architects as well around here. So now we will begin with the content. As always, we'll speak for 20 minutes or so, maybe 25, maybe 30. We'll take about 10 minutes of questions because we want to make sure that you guys learn and have a great experience. And I see all these hashtags, and we will begin. So if you'll recall, yesterday, we were working on networking, and the last thing we talked about were the transit gateways. So now we're going to talk about network access control lists or packet filters. So in any network, we have to find some way to keep traffic out of a subnet. On routers, we have access lists. On AWS, they call it a network access list, but it's really a basic packet filter. And with AWS, and here's your test question, we use access control lists or network access control lists to keep unwanted traffic out of a subnet. Later, we'll talk about security groups, and that's to keep traffic out of a host or service. And you will see that in the question. Network access list protects a subnet. A security group protects a host or service. So access control lists will either allow or disallow traffic based upon the configured policy you set. Now, when you put on an access control list, the default policy is to deny everything, just like a firewall. The normal firewall blocks all incoming traffic. And if you have an access list and there's no permit rules, everything is going to be denied. And when you create an access list, it's really like the old-fashioned Cisco extended access list, where you're going to specify the source and destination address, a protocol, and a port number. So access control lists are stateful, and we'll talk about what stateful means when we get to a security group. And I'll draw a diagram for you so you understand, because we have fun with our diagrams. But network access control lists are stateful, meaning the routers themselves, whether it be a virtual router in AWS or a Cisco router or a Juniper router or anybody else's routers, do not keep track of the data going in and out of the router with an access list, which means they're stateless. So on a practical perspective, you will need to apply an access list both on inbound traffic and outbound traffic. So keep that in the back of your mind. It is also important to note that with access control lists or network access control lists, the rules are processed in order. So the order matters. I'm going to show you what not to do. And I've seen this so many times. People say, Mike, I don't understand. No traffic's getting through my access list when I explicitly permitted something. So if I take you to this example, and I've seen this all the time, here's what you don't want to do. So let's say I've got an access control list on inbound traffic, and it says Rule 100, deny everything. Hey, Rule 110, permit web traffic in. Well, here's what happens when the access list is processed. The packet comes in, and it sees it, and it hits the access list that says denial traffic. The traffic's completely thrown out right there at that rule. And then what you'll see is after the deny everything, which means throw it all away, you got to permit something, but it doesn't work because it's already been blocked. So when you're going to create an access control list, here's the right way to do it. Create a rule that says allow TCP or whatever it is you want to allow in, IPsec to a VPN concentrator, TCP port 80 to a regular web server, TCP port 443 to HTTPS. So allow what you want. And that's it, because the rest is going to automatically be denied. And here you can see how we're allowing, the traffic in and the traffic out for a basic HTTP web server, just like a router that you get from Cisco. So next, I'll show you where this works. And we'll get to security groups in a minute, but the network access control list protects your subnets. Your security groups protect a host or a load balancer or something. So security group, think host-based firewall for a device. Access control list there. Now, you may have noticed that I had Rule 100 and then Rule 110. So remember, these things, access control list rules are processed in order. So don't do Rule 1, Rule 2, Rule 3, and Rule 4. And here's the reason why. As you work with these systems over time, you're going to need that, you have a rule and you're going to need to add another rule. And remember, these things are processed in order. So if you do 1, 2, and you need to add a new rule for rule 2, you're going to have to erase every other rule you have and then rebuild your access list from scratch. You don't want to do that. But if you did 10, 20, it gives you the opportunity to add, an additional 9 rules in between things in order. So always leave a good space between your rules. Okay, so let's talk about security groups right now. And a security group is like an access control list, but it's going to be applied to a computing instance. And it's very similar to a host-based firewall. And the difference between a firewall and an access control list is that firewalls are stateful. And we'll walk through stateful in a minute because lots of people are confused by this, but you don't need to be. And we'll make sure you're clear on it in a minute. So because it's stateful, and we'll show you, you only have to apply it on the one direction, which is inbound. And we'll show you what that means in a second. But if you get someone asks you, do you use a security group or an access list? You use both. And that's still not going to be anywhere close to enough for security, but you use both. You protect the subnet with a network ACL. You protect the host with a security group. So let's actually look at what I mean by stateful. I'm going to give you an example. We'll do it real time. And let me just draw this out. So in this particular environment, what you have is you've got a firewall. Okay. Now, what we're going to do here is we're going to walk through, kind of, an example of what this could look like. So let's say we've got a user, and the user sitting behind the firewall. I'll make the user very small. This is the troubleshooting coach at Go Cloud Careers. She likes to unplug cables, power off our OpenStack servers with her paws, but she also likes to use the internet. So let's see if I can flip this around. Okay, so this little girl decides she wants to go to the internet. And, where does she want to go? She's going to go on the internet. She wants to go to a website. Let's say it's tuna.com. Little Cindy loves tuna. And I've got the tuna bills to prove it. So the way a stateful firewall works, and a security group is a stateful firewall. Cindy wants to go to tuna.com. So she goes out. The firewall typically does her net. Her traffic goes all the way out to the internet, and tuna.com, gets the request. It's a TCP request. So little Cindy sends a TCP send to the website. Will you open a connection with me? And the tuna.com website responds to her send, and acknowledges it. Yes, I'll open a connection with you. And little Cindy, I want you to open a connection with me, so it'll send its acknowledgement as well. And then the packet is allowed through the firewall. I'm going to do this again because it's really important. Little Cindy wants to go to the tuna.com website. She goes out to the internet. As soon as her packet leaves the firewall keeps track of it. And the tuna.com's traffic is allowed back because Cindy initiated the connection and the firewall kept track of it. Now, over here, we have to understand the rest of this is over here. We have Hal the hacker. And Hal the hacker wants to actually get through the firewall to talk to Cindy. Hal the hacker hits the firewall and his traffic is automatically denied. And it's denied because firewalls block all incoming traffic. Block. And except what was specifically permitted. But firewalls by default allow internal traffic to go out to the internet. And it keeps track of that traffic. And that's how it knows how to allow the return traffic to come back. So that's what people are talking about when they deal with stateful firewalls. The security group is stateful, so you only need to apply it in one direction. So let's talk about the interplay of a security group and an access list. So here you see we've got our internet gateways connecting us to the internet. We should have a firewall too, but this is a very simple diagram. There are multiple firewalls and other things along the way, but let's just say this for right now. So we've got our access control list protecting the subnet where our servers are. And then we've got a security group protecting those servers. So it's a combination. When it comes to security, it's really like an onion. You're going to need multiple layers and layers and layers of protection. So kind of hope that clears that up for you. So the next thing we're going to talk about while we're under networking is something called a transit VPC. So yesterday we talked about hub and spoke networking. We talked about the efficiency of it. There's flaws with hub and spoke networking too, because if the hub goes, you've got a problem. And that's why you typically use multiple hubs in hub and spoke networking with multiple connections to each spoke. But hub and spoke networking is very simple. It's just like taking that airplane. And that's why the airlines use hub and spoke networking too. I live around Palm Beach, Florida. I want to go anywhere. I go to my West Palm Beach International Airport. I then fly to a hub. A hub could be Dallas, Texas for Houston for Delta Airlines. For United Airlines, it could be Houston, for example. For American Airlines, I could go from West Palm Beach to Dallas and then Dallas to somewhere else. So that's your typical hub and spoke. And a transit VPC enables an organization to connect multiple VPCs to themselves through a transit VPC. So the transit VPC is basically functioning as a hub in a hub and spoke environment. And for example, an organization could have multiple VPCs and they could run a connection across the internet to these VPCs, or they could get a direct connection to each different spoke site, which they could do, just like you would do in a normal wide area network. You buy private lines, use software-defined networking, VPN WAN across your spokes. But in this particular case, you're using the cloud as your network provider, and that's why you would use a transit VPC. So the transit VPC is really a cloud router. And what happens is the spoke sites connect, via a connection, obviously, and they connect to the transit VPC via BGP. And that way routes are exchanged, or network layer reachability is exchanged between the individual VPCs. And all the information stays on the AWS backbone, which means it's secure. And it's not on that scary internet like it would be, for example, if you happen to be using, say, any type of an internet connection. So great way to think about this. So let's talk about some improving the performance of some of the things you're going to be doing in the cloud. We're going to talk about first placement groups, and then we'll talk about single root IO virtualization. A crazy name. I didn't make it up. We'll make it real simple, explain it to you. We'll talk about things like Elastic Fabric adapters, Route 53, and we're going to talk about load balancers. So the first thing that I want to talk about are placement groups. So what's a placement group? Well, wherever your systems are, the further they are from each other, the greater the latency, which is why, for the most part, a data center on your building has the best performance, and it will perform better than a cloud that's, say, 1,000 miles away. There's other reasons to be on the cloud, like agility, but generally speaking, your best performance is next to you. So if you need high performance on the cloud or any data center environment, sometimes you put stuff closer together. Now, when you put stuff closer together, you trade off availability, because from an availability perspective, you want your systems as far apart from each other. But from a performance perspective, you want them as close as possible to each other. So there are times where you need to create a high performance and computing environment, and you might do that. So, for example, I had a bank that I helped build the fastest trading system in the world many years ago. And we had 2 racks filled with the biggest servers that we could possibly find, and parts of the data center. And for the most part, there was one, and everything was super close to each other, all on the same switch. And there was another one super close to each other, all on the same switch. And we had 2 of them, one primary and a backup. So that's really what we're talking about. So let's talk about the first kind of placement. And this is going to be called the clustered placement group. Best performance you're going to get on the cloud is with a clustered placement group. And here's why. You put your servers all in the same rack. Okay. Most of the time, your virtual machines are even in the same server. So if you've got one, if you're using one of these really cool epic, servers with these 256 physical cores and 5 logical cores, and your system's got like 8 terabytes of DRAM in it, chances are you got pretty good performance in that server. And you can put a lot of virtual machines in that server, and the data never even needs to leave the server. Talk about good performance. But I want you to think about this. You put all your stuff in the same server or the same rack. It's now in the same rack. The rack has something called a power distribution unit in it, where it gets power from the data center. If the circuit breaker blows on that power distribution unit, everything in the rack is dead. Now, often you use 2 power distribution units and you have servers that are plugged into both, but keep that in the back of your mind. Single rack, lots of stuff to go wrong. Switch fails, the entire rack is dead. Primary server fails, it's got half of your virtual machines. I mean, a memory or a CPU failure or a hardware failure, poof, crashed. You got nothing. But if you really need the best performance and you squish all your stuff in the same rack or the same server, you're going to get it. So that's what a cluster placement group is. All your stuff in the same device. You can see in one of the data centers called an availability zone, you got all your stuff in the same rack. Really good performance. Because it's not like there's any latency going back and forth between your devices or minimum latency, but all your stuff's in a single basket, super close to each other, so there's a lot to go wrong. So what do you do if you need good performance, but you need a little more redundancy? Well, this is where you get into what AWS calls a partition placement group. Here's what you're really doing. You're taking 2 or 3 racks in the same data center, and you keep a lot of stuff in, say, rack 1, a lot of stuff in rack 2, and a lot of stuff in rack 3. And the racks are relatively close to each other, and they've got high-speed fiber optic connections to each other, and you got good performance. Until that data center or availability zone goes, and you got nothing. But this is going to be what it's going to look like. Now, because all of your stuff isn't in the same rack, it's not going to perform quite as well as the cluster placement group. But it's going to perform pretty darn close to that because it's all in the same building. And this way, if you lose a rack or you lose a switch port or a switch, this has a lot better survivability. And as long as that data center doesn't go down, you're going to be up, operational, and good. So I hope that kind of makes sense. Now, the alternative is a spread placement group. And what's a spread placement group? Well, if we know that it's a little too dangerous to stick everything in the same data center, otherwise known as availability zone, we can put our stuff in maybe 2 availability zones across a couple of racks. Now, this will give us much greater availability than something like a cluster placement group or even a partition placement group, but it's going to come at the cost of performance. So what's that going to look like? It's going to look like this. We've got 2 availability zones and we've got stuff spread in multiple racks. So decent performance, but not optimal performance. Optimal performance is that cluster placement group. The partition placement group is kind of somewhere in between optimal performance and this, because it's still going to give you really good performance, but you've got a little redundancy in there. That whole data center you could potentially have. In a spread placement group, you spread the load across data centers. And if the data centers are close to each other and have good performance, it's still going to be relatively good. So kind of think about that. Now, the next technology I'm going to talk about, enhanced networking. So I hate these terms that marketing people make up. But in a virtual machine, and when we get to virtual machines, we talk about EC2 instances, I'm actually going to bring you into our data center, and I'm going to show you VMware at the server virtualization level and show you how virtual machines are created and what those hypervisors look like. So you really understand virtual machines or EC2 instances. Now, in a virtual machine, we have 2 options. Option 1 is we basically just use the CPU, the DRAM resources of the virtual machine, and everything is done on the CPU. But what if we need better performance? So in a traditional virtual machine, you have a virtual network card, a virtual graphics card, and their performance isn't great. Have any of you ever tried to video edit on a virtual machine? You're going to see it doesn't work so good because you don't have good GPU performance. Now, let's say, for example, I wanted to do AI on a virtual machine, and I need a GPU for the particular use case of my GPU, say an NVIDIA GPU, because I need CUDA. If I can't get a virtual machine to have its actual graphics card inside of the virtual machine, the hardware graphics card, I'll have poor performance. So there's a technology called PCIe pass-through, which enables you to take a PCIe card, like a network card or a GPU, and take that physical card and put that physical hardware inside of a virtual machine. And that way the virtual machine can have a real network card, like a 100 gig network card, or it can have, an NVIDIA RTX, say A6000 in it, or something like that. So kind of keep that in the back of your mind. So when we push a physical network card into a server, they call it single root IO virtualization. You may see it abbreviated as SR-IOV. All that means is you've got a virtual machine with a hardware network card placed into the virtual machine. That's it. And accordingly, a real hardware device will perform better than a software device. So the next concept we'll talk about as it pertains to high-speed networking is something called a virtual fabric adapter. And AWS invented a software network adapter that had a really good driver that can offer high network performance. It's designed for up to 400 gigabit per second. At some point, it may get there, but keep that in the back of your mind. So those are some performance tuning things. So we're going to get into DNS next, but now might be an actual good time to see if anybody has any questions. So let's see if anybody has any questions. If not, we'll get back to the content. The first question is, what's the difference between a security group and a firewall? So a security group is a firewall, if you will, for a host. But a traditional firewall will protect your entire network. So maybe if we draw it out, because that's a good question. And I may have a surprise for you at the end of this thing that will help you understand that a little better. So stick around till the end. You may have some surprises that you aren't counting on that you might really be excited about. So let's look at it this way. In a normal cloud environment, I might have a load balancer split the load against, say, 2 next generation firewalls. And behind that, I could have either an internet gateway, or maybe I've got a web server over here, for example. And I'll show you the difference in how you would apply these. So let's say we've got a load balancer and 2 next generation firewalls, and then maybe behind that we've got a load balancer and maybe it's an IDS IPS system. And even though the next generation firewall has it, sometimes we use IDS IPS systems for logs and security. And I'm going to put my web servers in a subnet. So inside of the I'm going to protect the subnet with an access control list. And then I'm going to have my web server back here, which is going to be behind a load balancer, right? Because we're most likely going to need more than one. So I'm going to have a load balancer. The outside of the load balancer will obviously need a public IP address because it's going to be reachable from the internet. So we'll call it E for a public IP address or external IP address. And behind the load balancer, we may have web servers. And these are going to be sitting on virtual machines in most cases. So here's what you see. This firewall protects the entire network. Everything. These intrusion detection and devices will also cover, certain things. It may spot an intrusion or find an intrusion, for example. This is going to protect our subnet. And on this load balancer, we're going to put a security group here. And that's going to be like a firewall to the load balancer. And then we'll also put a security group on the web servers. And, you're going to look at this and say, what the heck? Why so many layers here? You have to understand that if you don't have these layers, you'll still be hacked. And even this is not going to be enough to properly secure the system. We're going to have to harden operating systems and create a good identity and access management strategy. And there's a lot more that we could do here to even further increase the security. But firewall protects everything. I can put a firewall between two VPCs. I can be a computer parts manufacturer, and I might have to get hard drives from Samsung, and I might need to get GPUs from AMD and NVIDIA, and I might need to get Ethernet cards or other cards from, say, Mellanox. So I might put a firewall between my computer parts, my server manufacturing company, and all the parts providers to protect me. I might use a firewall to protect an organization from external threats. But I might use a security group as an extra step on the load balancer to say, hey, if anything past the firewalls and the IDS, IPS, and the access control list, I'll use the security group thing. But the bigger, more industrial tools out there I'm talking about provide a much greater level of security. But the more tools you have, the better your systems will be. Does a VPC have an IP or only a suggested range? So we have to understand a VPC is your virtual private data center. You might need 20,000 IP addresses inside of that or more. I work with organizations that have hundreds of thousands of IP addresses. So you are going to have an IP, you're going to have a subnet. Each subnets that you're going to have are going to have their own range. And for example, a server subnet typically is going to be a /24 because you might have up to 250 servers, more than you think you need. But private IP addresses are free. Wide area network links typically only allow 2 IP addresses, but with AWS, you got to make it a /28 because they use IP addresses a little differently than most organizations. So everything that needs to be reachable will have an IP address on it. Everything. Good question. Firewall would be in a transit VPC. Well, what you would typically do is you would have the router in the transit VPC doing running BGP and handling the routing. But if you wanted to protect each VPC from each other, so if one VPC kind of got hacked, you didn't want the other VPCs to get hacked, you would potentially put firewalls between every VPC and the transit VPC. You could do that. Nice question. The internet gateway to the VPC, does it have an IP address? It must have an IP address. So the outside, so the internet gateway is going to have a public IP address to be reachable from the internet. So yes, it will have to. Let me go to the next one, Chris. How should you design a landing zone for internet access and firewalls for applications? So you wouldn't design a landing zone for an application. You would create something called a demilitarized zone. And in that demilitarized zone is where you're actually going to set up your systems up. Now, how do you design proper demilitarized zone based upon your application? I typically spend about 800 hours teaching those things to my cloud architect students and network architect students. And that's why so that's where I would say to learn that. If you can't take that training with us, I would say you're going to need a security architecture training from someone, and it's not going to be covered something in, say, an AWS Advanced Security. It's just not. Some of it's covered in the CISSP. I'd say some of it, but a lot of it is really understanding security technology. So a CCDE from Cisco, they would talk about this. A CCIE security from Cisco, they would talk about this. But you have to evaluate what the application is. You're going to have to evaluate what it's worth, the application, the critical downtime, and as you have to understand, what is downtime cost? Is it $1 million a minute for this application? You have to understand what is the application protecting in terms of quantifying the security. And then you're going to need to build a business case around it and then figure out what you want to do about it, for example. Do you transfer the risk with, say, insurance? Do you mitigate the risk? Which risks do you just accept? Those kinds of things. And that will determine how many layers of next generation firewalls you use, ITS, IDS, IPS systems, which SIEM systems you're going to be using along the way, how you're going to harden the operating systems of your servers themselves, what traffic needs to be in and out, those demilitarized zones, and there's a lot that goes into it. But it's beyond the scope of what we can talk about here because of time. Good question, though. So, Mohammed, when you've got overlapping IP addresses, you have to do something about it. Either readdress your overlapping IP addresses or use network address translation, because you can't have two devices talk to each other if they have conflicting IP addresses. But so the transit gateway is not going to natively do it. But a transit VPC can handle overlapping IP addresses with very careful net design. So, Aref, you said you worked in 20 years establishing and maintaining racks and servers and managing VMware infrastructure. Now everything is cloud-based. So where is the expertise going to be? Well, it really depends where you want to be and what you want to do. Everything that the VMware data centers have been doing is no different than the cloud. I mean, seriously, it's 100% the same. It's the same physical data centers, the same racks, the same load balancers, the same everything. So it's just whether they use a VMware hypervisor or their own hypervisor. But all in all, it's going to be the same. So the key here is understanding that there's going to be a lot more automation in the racks and managing the servers. So if it's going to be cloud-based, you're going to have the opportunity to whether you build the stuff or whether you design the stuff. So I don't know what your actual goals are. And depending upon your actual goals, I could give you more guidance. The best thing I could say is attend one of our live webinars or do one of our career question and answer sessions, because I want to answer it and I will answer it. And normally speaking, every Monday I do free question and answer sessions. And every Thursday I've got a webinar on Zoom, and you can ask as many questions as you like that on careers, and I would love to answer it. But because this is certification based, we can't really talk about the future of careers at this point, but potentially later. But I will definitely help you with it. But I can tell you, AI architecture, cloud architecture, enterprise architecture, security architecture are probably some of the best careers moving forward. And my team can pop a link in a chat box of why we feel they're the best way. And I just wrote an article that was just published in a magazine today. It was on LinkedIn where I was tagged. Maybe my team can drop a link to that as well. Is it considered a firewall for EC2? A security group it's what you would consider a host-based firewall. So what do I mean host-based firewall? So a host-based firewall protects a host. A traditional firewall can protect the entire system. So yes, it's a firewall for an EC2 instance, for example. But that doesn't mean you might still not want to put a host-based firewall on your EC2 instances. Maybe you use a security group to protect your instance, and maybe your endpoint also has a host-based firewall, some anti-malware software on it, and it's going to have some other things attached to that host as well to keep it secure. Okay, so let's get back to the content. And we are now going to talk about DNS, our Route 53. So why do we have the DNS, or the domain name system? Here's the thing. Every device on the network needs an IP address. And if you've got a memory like my wife, where you could just give her a number, 3.14.76.21, and that is an IP address. I have no idea who owns it. My wife could remember every single one of them and go, oh, this cat site, let me enter that number. Of course, my wife learned Spanish in 2 weeks because her translators couldn't understand our thoughts, so she's a super genius. For the rest of us, I know that it's very easy to type www.gocloudcareers.com. And I don't have to think about the 2 IP addresses that we have of the 2 web servers. So DNS helps us map a name to an IP address. And there's a lot of things that are here. So here's an example of how this might work. You've got a user that enters www.amazon.com on their browser, and it sends a request to the DNS server, who has the IP address of Amazon.com. And DNS will return the IP address for Amazon, and then you're there. So I'll teach you actually how you can find the IP address to this later today. because we're going to check it when we talk about, or if not, we'll talk about it when we get to content delivery networks. But here's an example of, I went to my PC and I did an NS lookup, which is how you would check the name to an IP address. And I typed NS lookup www.gocloudcareers.com. Those 8.8.8s that you have are my DNS servers. They're actually Google's Anycast DNS servers. That's great DNS service. And you can see these are the two IP addresses of our website, a primary and a backup. So now that you understand what that is, and actually, if we go back to this, which do you think is easier to remember? www.gocloudcareers.com or 192.0.78.137. And at least the way DNS is set up, and we'll talk about it later, if the first web server were to fail, DNS would route you to the second address. And that's another reason we might be using DNS. So let's talk about what goes into a domain name. We've got a host name. That's the name of the end device. So we also have the domain name. And that's going to be the domain name that we're talking about. And I'll discuss this in a minute. And then we will have the top level domain. So what's that going to look like? So www, in this case, would actually be the host name. It could also be Mike.ec2, but whatever. In this case, we'll say www is the host name. The domain name is going to be Go Cloud Careers, and the top level domain is .com, .net, .edu, .anything it's supposed to be in today's world. So that's what goes into a fully qualified domain name. And when a domain name has everything, it's called the fully qualified domain name. So the way DNS works is it has DNS records. They're also called zone files. And what are DNS records? They're really just a particular set of instructions that are located in the DNS server on how they work. So the records are going to be in a format that's called DNS syntax. And realistically speaking, it's a text file that sits on these DNS servers. And there's going to be a couple things that exist. There's going to be something called a time to live. You may see it as a TTL. And that's going to be how often your DNS servers will refresh the records. So you've got a choice of short TTLs or long TTLs. And normally the time to live is measured in seconds. If I set the time to live to 1 day, the DNS server would not refresh itself for 1 day. So what would be the advantage of this? Well, if it was 1 day, those DNS servers don't have to do a lot of work. They're attached to a certain number of people, and once a day they get a little text message, and they're sitting there happy. They're relaxed. They're not doing anything. Of course, if something happens, you might not know about it for a day. So that's not going to be good for your availability or anything like that. By comparison, if you set your DNS records very short, the TTL very short, those DNS servers do a lot, but they will find an error quickly and they will refresh it and get it better. So you're going to have better performance and availability. So an organization needs to think about the scalability of their DNS system and what they're trying to do. Now, we're going to talk about the DNS record types, and I'm going to talk about something that you really should consider. If we're going to be talking about AWS Route 53, and I want you to understand that if we have a multi-cloud environment, which 98% of businesses do, say a Nutanix cloud and AWS and Azure, and we use AWS DNS Route 53, and AWS has an outage, our Google will be down, and our OpenStack cloud, our Nutanix cloud will be down. So if it's really going to matter in real architectures for real large global important enterprises where downtime matters, you can't use Route 53. You'll have to go to a DNS vendor like F5 and put your own DNS servers in all clouds. So if it's going to be critical, like a multi-billion-dollar architecture, and that's all I work on, you're going to have to manage your own DNS infrastructure. But if you're looking for the convenience of somebody managing your DNS infrastructure for you, and you're not that scale, AWS, assuming your business is going to only be on AWS, which again, 98% of businesses won't be, has this managed DNS service called Route 53. So keep that in the back of your mind from an architectural perspective. So now we're going to talk about various records. The first record is going to be called an alias record. And thankfully, this works for all DNS providers. So An alias record is something very similar to what you would think of a CNAME record, but it can be used to point to a DNS node. So if I want to map www.a.com to www.b.com, where when the user goes www.a.com, they automatically get transferred to the new website, www.b.com, you create an alias record. And you may have noticed companies change names or grow over time or buy a company, and you go to the old website and they transfer you to the new one. Well, that's either going to be done with the CNAME record or it's going to be done with an alias record, depending upon whether it's a subdomain or primary domain. The next DNS record type that you should know is something called the Certification Authority Authorization Record. And that enables domain owners to specify which certificate authorities are allowed to issue certificates for their domain. Maybe you get a certificate from the Amazon. Maybe you get it from GoDaddy. Maybe you get it from another company. There's lots of certificate authorities out there. And that's what your CAA record is. And why? Because if you're supposed to be getting a certificate from GoDaddy and it's being generated by Holly the hacker, you got a problem. Don't use it. So that's what that record's for. You're also going to see something called the TXT record. And a TXT or text record is used to store text information for a variety of purposes, maybe verifying domain ownership, providing some email sender policies, and implementing other services that are going to require textual data. You'll also see something coming called the PTR record. PTR or pointer records are going to be utilized for reverse DNS lookups, allowing the mapping of an IP address back to a domain name. So if you know the IP address, meaning like somebody tries to come and hack you, and you see their IP address, and you want to contact the ISP that they're at and get them banned, you might use a PTR record, for example. Now, you'll also have another record called a naming authority pointer record, and that will be an NAPTR. I didn't make these up. And they're often used alongside something called an SRV record for advanced DNS routing needs. Now, there's another type of a record called the Sender Policy Framework record or an SPF record, and that helps protect against email spoofing by specifying authorized mail servers for a domain. And if you know who your mail servers are supposed to be, when you get an email from your boss that says, "Hi, it's the CEO. Please go to the Apple store. I'm short on time and go buy some gift cards and I'll give you money back later," you'll be able to know that that didn't come from the CEO. And if you ever get a text message like that or an email message like that, and it happens all the time, it's called CEO fraud, know that it's not real in most cases, unless you've got a manager that constantly asks you to go to the Apple store and buy gift cards. You will also see something called an NRV record, and this is called the Negative Response Verification record. And it's not super common, but it's designed to authenticate negative responses in DNS queries and ensuring that the responses are indeed from authoritative sources. So these records that we've talked about each fulfill specific functions of DNS management, from domain verification to email security to directing traffic for overall security. Now, I talked about why, in a multi-cloud environment, you need to have your own DNS infrastructure. But if you wanted to use the Amazon one and your services and you're one of those 2% of the customers that are only in a single cloud, you can use AWS Route 53. And it's a great DNS service. It just is. But if you've got 3 clouds and all your DNS is managed by one cloud provider and they're down, you lose the benefit of the other 2 clouds. So keep that in the back of your mind. Architecture is all about trade-offs. Is the trade-off right for your business? So when it comes to AWS, they use Anycast service, which is really good. Anycast provides low latency and it supports health checks. So what is Anycast? Because this is going to be something that confuses so many people, but it's really great from an availability perspective. So let's map it out. If you'll recall, every IP address in the world, it needs to be unique if it's going to be reached. So let's say DNS, and I'm going to use Google's DNS addresses because I know them, and Google's own DNS is, is Anycast as well. So let's talk about how Anycast actually works. You're going to have 2 servers that are going to have the same DNS information on them. They're going to be identically configured, and they're going to have the same IP address. What? Huh? Mike, didn't you say that every IP address out there needs to be unique? And I said, yes, there is. And that's completely true. But for right now, just work with me. And this is how these DNS systems create some real high availability as they use Anycast. So we're going to walk through. So let's say we've got the internet over here. I can't seem to find my cloud that I'm actually looking for. So we'll just, I'm going to make a big circle for the internet. So let's say this entire thing over here is the internet. And this is why Anycast is so cool. Now, let's say you got a user over here. You got a user, and this user's in Florida. And this user over here, they're in Tennessee. And let's say this DNS server is in Florida, and this DNS server just happens to be in Tennessee. So, and the reason Anycast provides high availability is this. So I want to go to the internet, and I want to know who has the IP address of www.gocloudcareers.com. So I enter that in my browser. My PC does a lookup, and it says, go to 8.8.8, Mike. So I go to 8.8.8, and I get a response. Now, this is why it's so cool. If this DNS server were to go away and die because the server crashed, guess what will happen next? And this is what we do in most high availability situations. So my PC is configured, go to 8.8.8.8. So my PC goes to the internet, and it hits the DNS server, which happens to be in Tennessee. And then it gets a response back from the DNS server, and I know how to go. So by using Anycast, what happened so far is my DNS server went away, and all my PCs are configured for the same DNS address anyway. So my service is up. What makes this even better is we've got some users. There's a great business school at the University of Tennessee at Martin. I know some phenomenal business school and professors that teach there. And they want to go to the internet, and they go to their Tennessee web server, and they get a response. But if this thing were to crash, they'll go and they'll hit the Florida web server. So that's the point of Anycast. It gives you great performance, and it also provides high availability. So in any environment where you're going to use high availability DNS, it's going to be an Anycast setup. And whether it's Google's DNS servers that you're using, or AWS's DNS servers that you're using, or Azure's DNS servers, they're all going to be Anycast. But like I said, if you've got a multi-cloud environment, you need to have your own infrastructure that can survive a cloud failure as well, even though these cloud providers have really good DNS services. So there's some other DNS records that you need to know, and we'll talk about them as well and what they actually do. So we talked about most of these, but these are some records you should think about. The A record maps a name to an IP address. The AAAA record maps a name to an IPv6 address. The C name record is if you were to enter training.gocloudarchitects.com, you'd be forwarded to training.gocloudcareers.com. So, it's that kind of thing, so that you get the information no matter what. The MX record is for mail. We talked about some of these other records already, but keep these in the back of your mind. These are the DNS records that, generally speaking, you should know for your career. And they're also the DNS records that you should know what they are for your tests and exams as well. So AWS supports that A record. They support C name records, as we talked about. AWS supports NS records, our name server records, which these are going to be the name servers that will be responsible for your DNS zone. These are the authoritative name servers that propagate your official DNS information to the main DNS servers across the internet. I mentioned the MX record is going to say which mail servers can accept mail for your domain. When it can email, you have to have an MX record. The start of authority record identifies the primary name server for the domain, the responsible party for the domain, and it has a timestamp that changes anytime you update the domain, and the number of seconds before the zone should be refreshed. Amazon Route 53 supports both IPv4 and IPv6 addresses. And DNS, all DNS, including Amazon's Route 53, does something called the health check. And I want to draw that out for you because this is a very important concept. And not everybody understands it, but if you do, you'll be much better prepared to not only pass an exam, but actually be able to be functional and work. So here's what a health check is. Let's say this is server 1. We'll make a couple of servers here. Server 2. Server 3. And this could be a router doing a health check, a load balancer doing a health check, DNS doing a health check. So in this particular environment, let's say it's going to be DNS. I don't care whether it's DNS or a load balancer. They all do the same thing. Now, let's say these are all 3 web servers that we want to use. We got 3 of them right now. It's exciting, right? So DNS, let's say traditionally, it sends 33% to server 1, 33% to server 2, and 33% to server 3. Now, these servers could be in different clouds, different data centers, or they could all be in the same data center. Just we've got a weighted routing policy that does 33% to one, 33% to the other, and 33% to the third. Done. Now, here's where it gets pretty interesting, and it's going to get exciting. Here's the way this works. The DNS server will issue a health check, and here's what it's going to do. The DNS server will query server 1. Server 1, are you there? And server 1 says, I am here, I am present. So DNS will consider server 1 to be good. Right, immediately thereafter, DNS will question server 2. Server 2, are you there? And server 2 says, I'm here, I'm part of the party, I'm having a great time. DNS says, server 3, are you there? Server 3 says, woohoo, having fun here at the pool party, serving my web content. So everybody's happy. And this goes on all day. The DNS asks the servers, they, are you there? They say, I'm here, and everybody's happy. Now, somehow, server 1 crashes. And DNS says, server 1, are you there? And server 1 doesn't respond. So, of course, DNS, tries a couple of times and says, server 1, are you there? Server 1 doesn't respond. DNS says, server 1, are you there? DNS doesn't respond. So what happens is DNS will look at this server as dead, muerto, Bethameni, whatever language you want to think about it in. And DNS will then know, don't send any more traffic to server 1. Send 50% now to server 2 and 50% to server 3. Now, if DNS does a health check and server 1 says, I'm back, then DNS will share the load all over again. So that's the concept of a health check. Hope that kind of makes sense. So now we're going to talk about the types of routing policies you could do on AWS Route 53. Guess what? For the most part, you can do these same routing policies on Azure's DNS, Google's DNS, F5 DNS, any kind of DNS situation you want. So we'll talk about these policies and typically speaking when you would use them. The simplest DNS policy is called simple routing. What's simple routing? You've got one server, right? Or maybe a couple of servers. And you basically pop a simple record that says, if you go to 1.2.3.4, go to this server. I should say, if you want to go to cindythecat.com, and I don't know if that's a real website, but I've got a cat named Cindy the Cat. So if you go to cindythecat.com, it takes you to, let's say 1.2.3.4. Let's pretend that was Cindy the Cat's website. It's not, and it's a public address. So it's just an argument. And don't go looking for Cindy the Cat at that address. So keep that in the back of your mind. Simple record. So you can think of it as something like this. Send the traffic, maybe go cloud architects directly to our web servers. Simple. So let's talk about another DNS policy called weighted routing. And weighted routing is how you can effectively choose how much traffic you're going to send to different resources. You would use weighted routing if let's say you have a data center right now on a private cloud, and you want to have 50% of the traffic go to the servers in your data center that are already paid for, and send 50% of the traffic to the AWS cloud. That way, you could have two clouds running, your data center private cloud and the AWS cloud. If your data center crashes, guess what? AWS could take over with auto scaling the entire load. If AWS crashes, don't worry, you don't lose your traffic because you still got your data center. You could have it with two cloud providers, 50% to AWS and 50% to Azure. Azure goes down, 100% of your traffic goes to AWS. AWS goes down, 100% of your traffic goes to Azure. That's weighted routing. And why might you use weighted routing? So you might use it for multi-clouds, but let's say your application developers tried something new, and one of your deployment methodologies is send 15% of the traffic to the new application and 85% to the old application. And if it works well, the traffic that went, the users loved it on the new load balancer where the new web server is. They loved it, and it works. Then right after that, you point everybody to the brand new application and all the brand new servers. So you might do that for, say, a weighted routing. I think they call it a canary deployment. I'm not an applications person. I'm a cloud architect, enterprise architect, and network architect. But there's an application deployment methodology. I'm pretty sure it's called canary deployment, where you send it to, say, 10%. If it works, you send it to everybody else. So let's talk about the next approach, which is something called latency-based routing. If you want your users to have the best performance, you want them to have the lowest latency. So the way latency-based routing works is DNS will look at your IP address, and they will send you to the website that's closest to you. So if I'm in Florida and Atlanta, Georgia has my website, they'd send me to the one in Atlanta, Georgia, as opposed to the web server in, say, London, England, or Tokyo, Japan. It's going to go to the nearest region. So that can often improve your performance, and that's called latency-based routing. So it's really about this. If somebody wanted to come to Go Cloud Architects from Australia, it would be better to send them to the load balancer that's closer to them. Very simple to understand. So hope that makes sense. So now let's talk about failover routing. This is pretty simple to understand. Failover routing is when you create an active setup and a passive setup. So for example, let's say that you had 100% of your systems in the AWS cloud. Let's say you had 100 web servers, for example, in AWS. And you had them in 2 different availability zones, but you wanted some kind of really cool backup. Let's say you had 10 web servers sitting in Google right now, running actively all the time, but nothing happens. You could set up a routing policy where if AWS were to fail, DNS would run those health checks and determine that AWS is down. It would then shift all your traffic over to Google, which has 10 servers running. Those 10 servers would immediately pick up the load. And then auto scaling would bring those 10 servers in the Google Cloud to, say, the 100 servers. And within 45 minutes, your data center is 100% up on another cloud and partially up in between. You could also set up a failover routing policy where, you've got your data center. And if your data center were to fail, go to the AWS cloud as a backup. So you've got lots of options in your architecture of how you design these. And DNS will be a significant tool on how you do it. So, for example, in a diagram we drew for back when we were at Go Cloud Architects, we just train more than just cloud architects. We train all kinds of architects, and they work everywhere now. So we're Go Cloud Careers. So if you put www.gocloudarchitects.com into Route 53, and the primary site would be unavailable, it would be deemed unhealthy, and all the traffic would go to the secondary site. So let's talk about geolocation routing policy. Geolocation routing policies route the user to the website that's closest to them by looking at the source IP address. And there's lots of reasons you might want to do this. So it's going to see where you're at. So If I am in the Bahamas, it's going to send me in a perfect website to a website in the Bahamas, maybe a website in West Palm Beach or Fort Lauderdale or something that's going to be pretty close. Geolocation. But I want you to think about this. Let's say you're in a part of the world that has many different languages. Geolocation knows which country you're in, and it could potentially send you to the right website. Think about that. It's kind of cool, especially for multinationals. So we'll also talk about something called a multi-value answer routing. And I have a hard time using multi-value answer routing, and here's what it does. It's kind of like a simple record, but it enables you to go to multiple destination servers, and then at random, it determines where it's going to send your traffic. Send this to the first one. Flip a coin, send it to the third one, that kind of thing. So for me in architecture, the better your plan is, the more likely your architecture is to succeed. Most architectures fail, like 70% of them. So the better your plan is, the better your results are. When you have no idea and you leave it up to random, that's not a plan that I really want to follow in most cases. There's still times to use this, and if it's appropriate, I'll use it. But in most cases, it's better to know where your traffic is going. Now, the next one we're going to talk about, realistically speaking, and it's one of the last things, is going to be geo-proximity routing. And what the heck is geo-proximity routing? This is an Amazon thing. And it lets Amazon route your traffic resources based upon the location of your users and your resources. And what it does is it takes different geographic regions of the world and it'll shrink them or make it bigger by something known as bias. And you get to determine what that is. So it's a unique one. You see, you've got these geo-proximity maps, which part of the world is. And you could make region 2 bigger or smaller, and that's how it's going to route your traffic. Hope that makes sense. So let's talk about DNS-based load balancing. So at the server level, you're going to use load balancers. At the network level, your routers may load balance either per packet, per flow, based upon the routing protocol and the way your routers and switches are configured. Actually, you know what? Before we get to this, let's do some questions, and then we will get back to DNS-based load balancing. Okay. What would cause an NS lookup to give a forbidden address? So a forbidden address could be caused by a few things. The DNS server could be configured to block queries for that address. There could be a firewall rule that's blocking the DNS queries to your server, or there could be an ACL involved. They're typically the reasons you would get a forbidden address. I think, Chris, we can go to the next one. What may cause some clients not to pick up an IP address when configuring DHCP, even if the config is properly done? So we're not really talking about DHCP now, and we haven't talked about anything related to that. But here's the way the DHCP process typically works. A host sends a DHCP discover packet, and this DNS servers respond, and then the host accepts one. So there's lots of things that can occur. There are times when the DHCP server is off of the local LAN. And DHCP, by definition, that discover packet is a broadcast. So the routers that actually are on that underlying network need to be configured to forward that all Fs broadcast to the appropriate DNS servers. With a Cisco router, that would need to be configured as a helper address. There are other times where the DNS servers are just not reachable because there's a networking problem. Now, there could be no IP addresses that are left in the DHCP pool as well. or a client could be misconfigured. You could have that that virtual machine configured to actually have a manually assigned IP address versus a DHCP assigned address. Or you've got some kind of security access control list or firewall that's blocking your DHCP traffic. They're your primary reasons where you won't pick up an IP address via DHCP. What is the diff? Simple record and geolocation and weighted. So I'm not sure what you mean by diff. So let me talk about a simple record. It just maps a single IP address to a domain with nothing complicated in there. A geolocation record routes traffic based upon the geographic location of the user. So it's going to send them to the most appropriate local server or the closest server. A weighted record sends traffic across multiple addresses. So send 50% to AWS, send 50% to Azure. That's a weighted record. I hope I answered your question correctly. I didn't know what you meant by diff. Use case of public zones and private zones. So private zones are for inside of your network. So in any corporation, you're going to have your intranet. And that's going to be all the private IP addresses and all that organization's private stuff. So I might have an internal server that's in my network that's got, say, a 172.161.7 IP address in the /24 range. But I might not know how to remember that IP address. So I might have DNS that says, hey, go to Cindy the Cat's tuna server, for example. And inside of your VPC, you might want also to do something similar too. So let's say you want to be able to reach certain virtual machines or a database by their fully qualified domain name. That's when you're going to use a private zone. By comparison, if you've got a publicly facing website or a publicly accessible load balancer or a publicly accessible API or a publicly accessible email server, that's going to be in a public zone because that's going to be reachable via the internet. And that's going to provide global accessibility for the people on the internet versus your internal users. Okay. What is the role of public and private keys, and how do you find them for an SFTP connection? So public and private keys we will discuss when we discuss security. But it's related to setting up encryptions, and we'll talk about it with certificates. We'll also potentially talk about it with email signatures if we get to that. Which DNS we use for weighted routing in case of multi-cloud? Well, it depends on your architecture. So the key with architectures is there's never one option. It's always based upon what you need. If I have two clouds, say two availability zones in two different clouds, and I want to use both clouds, I'm going to use weighted routing. 50% cloud provider A, 50% cloud provider B. Cloud provider A goes away, send the rest to the other cloud provider and let auto scaling take care of scaling out the system, and we're good to go. I might have a disaster recovery environment where I have, let's say, 500 servers running normally, and that's going to be a small number, and I put 50 servers running in the other cloud. And I may have that active standby kind of thing. So cloud provider A gets 100% of my traffic. Cloud provider A disappears. I go to the other cloud and let auto scaling fix it, and within 45 minutes, we're up and running. That could be used for disaster recovery, sort of that warm standby approach, but it could also be used for active and passive routing as well. So what's the goal that you would use in multi-cloud? That's really the key. All goes down to what your goal is. There's the other option we could choose too. Is DNS only used to communicate between a load balancer and an EC2? Absolutely not. DNS is used everywhere. Anytime you want to connect to any machine on the internet by its name, you use DNS. Anytime you want to determine which cloud provider you're going to go to, you use DNS. So lots of reasons to use DNS. How to route to multi-clouds? What is the median? Well, what are you trying to do? So, you can route to it. Well, do you want to have private lines between your clouds? Do you want to have IPsec connections to your other clouds? Do you want to have a software-defined WAN, which gives you, almost private line-like protection? Do you want to use a SASE WAN and get firewalls and encryption and some software-defined networking at the same time? What is the way you want your traffic to go? Do you want one prioritized over another prioritized? And that stuff you would do with BGP. But what is the goal? And that's really the key. So I can tell you that with a network architect, how they would route to multi-clouds is about 1,000 hours of training to really get to that BGP and that really heavy. And that's why a CCIE certification takes 2,000 to 5,000 hours of study and preparation time to get there. But everybody is multi-cloud. So you could do some of it via DNS if you're dealing with web servers. But what if it's internal stuff? And, and even if you have 3 clouds, you're going to have to synchronize your data, and that's going to be dealing with your routing protocols. It's also going to be dealing with your wide area connections. So if you ask a more specific question, like how do I route and send 50% of my traffic to A to 50% to B, I can tell you. But how do you route to different clouds? That's where you're actually getting into something that could be 50 different or even 500 different scenarios. But, the median is really for managing routing, and it's kind of a centralized control plane tool for network orchestration that's going to handle some of it. But you need to know what your goal is long before you think about using median versus BGP versus a software-defined strategy, that kind of thing. Good question. What's the difference between latency routing and geolocation routing? So latency routing is based upon the server with the lowest latency in terms of milliseconds, for example. Geolocation routing is the one that's closest to you. So they're going to be very similar. So if you think about it to this, the latency-based routing is based upon your geography. The geolocation could be something different. So let's say you're in a country. And let's say you're in Canada. And there's and let's say Montreal is predominantly French, right? But Toronto might actually be, more English and less French and more English. So you might want to, and this is a great question, Miriam, you might want to know where your user is. And that way you route them to the English one or the French one. Or say you're in South America. And Argentina speaks Spanish, but Brazil speaks Portuguese. So you wouldn't want to have a user in Brazil get a Spanish-speaking website. You'd want them to go to the one that's big in Portuguese. So that can be an example. There's some cultures in the Middle East that speak 3 and 4 languages, for example, and you want to send the users to the right place. That's typically where you're doing it. So give you a little more information. Latency-based is to give you the lowest traffic, the lowest latency and best performance. Optimize server response time. By comparison, geolocation is based upon the geographic location of the user. Can give you content or languages that's location specific. Or there are times where you need to comply with a regional policy. Your traffic can't go out of this country, that kind of thing. That's where you would use geolocation as well. Good question there, Miriam. And I know you will like that. Can I elaborate on the difference between geolocation and geoproximity? Sure. Geolocation is based upon your geography. So I'm in Brazil, I get a Portuguese website. I'm in Chile, I get a Spanish website. Granular routing. By comparison, geoproximity routes traffic based upon the geographic location of the users and resources. And you've got ability to shift traffic sort of towards resources. You're using geoproximity to optimize performance and balance load by adjusting that proximity bias. And lets you get pretty and able to really tune your flow of your traffic by specifying a bias. So I hope that makes sense. Any more, Chris? Geolocation routing and link to base routing. So I'm not completely sure I understand your question here, but I have a thought. For anything that's beyond the simple DNS questions that we're trying to cover now, in our AWS Advanced Networking Bootcamp, which you can get completely free, I'll have my team drop the link. I think we spend 3-4 hours on just DNS concept, maybe even 5 or 6 hours. So we've got a lot of content on there. And Tunde, I think that might actually be best to guide you, since I'm not sure I completely know what you mean.
I almost wonder if they mean latency-based routing. Maybe there's a language and the way maybe he said it, spoke it too fast, or it stutter on their jitter on their end.
Okay, okay. Yeah, then let me.
I'm just looking at it. I'm thinking latency-based, link-based. Like maybe that's what they meant.
Yeah, exactly. Okay, let's do that then. So, geolocation-based routing is to route traffic based upon a geographic location. So you get the right language, for example. Whereas latency-based routing is based upon the lowest latency. So if this website has less latency, go there. And it's typically based upon your source IP address. But the geolocation is making sure that you get the right one with the right language. You mentioned that AWS DNS would not work if AWS fails. Azure DNS would not work. Correct. If Azure fails, which DNS would you use in a multi-cloud solution, since you will not use AWS or Azure? So, Canner, it depends on the organization. Most organizations at the enterprise level actually use F5. They've been making the DNS servers that most enterprises use. You can also create your own DNS system using Bind. I think that it's on Linux servers, so it's been out there. But there's lots of ways you can do it. But you got to look at it. It's the same thing when we get to Kubernetes. If we use the Amazon Kubernetes service and Azure goes down, then our AWS and our Oracle clouds won't work either. So you got to use something based upon what you need. But typically speaking, F5 is a vendor that's well known in the DNS space. And you can put DNS servers in each one. Alternatively, there's other providers like Cloudflare provides great DNS service, but then Cloudflare becomes your single point of failure. So if it's really big and it's really going to matter, you're going to get an industrial solution. You put your DNS virtual machines in all your cloud providers. Okay, so a couple thoughts. If you're having a good time, please like the video. Maybe subscribe to the channel and hit the bell to be notified of new things that we can do to help you for your career. Because we are going to spend 10 days going pretty geeky and deep in content. I don't get to get geeky. I'm an architect. Most of what we do is at the business level. But because we're having fun getting geeky, I want to make sure you still get those hands-on labs and time to do them. So please download the 40 plus labs that we have for you. It's not a download. You'll sign up. You'll enter our content delivery system, and you'll be able to watch the labs and do them on your own. Please download them. My team will provide a link for this in the chat box, as well as a description of this video. Give me a hashtag and that says AWS Solutions Architect Associate, so that I know you're here, that you're not sleeping, that you're not hanging out eating cookies, which sounds really fun to me, even though I don't eat cookies, or playing with your cat, which sounds fun to me. I got a beautiful cat. But let me know you're awake, alert, and oriented with the hashtag AWS Solutions Architect Associate, and then we'll get back to the content. Do internet gateways also use Anycast like DNS servers? No. You need to know exactly which router you're doing. So if we were doing a router and a wide area network, there are types of first hop redundancy protocols that we could use. Things like HSRP or VRRP. And they are Anycast-like, but they are not Anycast, and they are used for routers. Internet gateways, again, are going to be a logical device, though. So logical devices typically don't go down, but routers use different technologies as a rule. Okay, I'm saying this. AWS, that'll sort of work. Lots of these AWS Solutions Architect Associates, some hashtags AWS. Well, okay. As long as I'm seeing these AWS Solutions Architect Associates, I know you're awake. And that way we're having some fun. So, and let's get back to some content. So now let's talk about Route 53 DNS-based load balancing. So how does it work? DNS-based load balancing just sends your traffic to multiple other devices. It could be different load balancers, different web servers, what have you. So how does it work? DNS or Route 53, if you're using AWS's DNS, would respond to your DNS queries with a different resource based upon your load balancing methods. So it enables you to load balance your application traffic across different regions of AWS, different cloud providers, if you will. And it works via health checks and DNS failover, just like we showed you when we walked over a health check. So if you weren't here for the health check piece, go back. We actually walked through health checks, and we'll probably do it again under load balancers. So there are, realistically speaking, two types of Route 53 DNS-based load balancing, and they're really routing policies. And they can be simple policies, and they can be complex. The simple method just takes two or more resources and load balance it. Puts one in primary and one in secondary. And if we're using this, Route 53 will always replies with the client's IP address of the resource in the active, unless it fails a health check, and then it goes to the secondary resource. Now, the complex DNS routing policy is going to take more things into account. It's going to look at latency, and then it will send the DNS response with the response to the server with the lowest latency. And this is on the client where it's coming from. So remember, Route 53 is a global service. So with clients, they'll hit DNS, will hit the DNS authoritative server and their region. So I hope that kind of makes sense. Simple, basically primary backup. Complex, send it to the resources that maybe have the least latency, which means best performance. So how do you set up DNS load balancing? Well, setting up anything is relatively easy in the AWS cloud or any other cloud provider. So the first thing you need to do is create your health checks. Create a health check for your resources. And, if you've got a web server that's going to be open on TCP port 80, make sure your health check opens TCP port 80. If you've got a web server that's going to open on TCP port 443, then it's going to respond on TCP port 443. Then you got to create your DNS records. So create your DNS records. And then set up a DNS policy, like create a failover routing policy. For example, if you want a primary and a secondary. Designate your primary resources and your secondary resources. And you're going to specify what happens under which circumstances. Set up your health checks and link them to your DNS records so it knows what to quote. And then just validate your configuration. So pretty easy thing to do. So here's a graphic that someone from my team, I think, drew. So on the left, we see an environment that's healthy. The DNS is going to say send it to your two different regions. Send half to US East and half to US West. Now, figure 2, set it load balancing between AWS regions. You can see that US West had an outage, and it's going to send all traffic to US East. So that's really what we're talking about here. Or better yet, in a high availability situation, you might be routing to 2 availability zones in AWS and 2 availability zones in, say, Azure. And that way you're pretty covered for lots of attacks that can occur. Or lots of problems like a network failure on a cloud provider, a control plane failure on a cloud provider, or a hacking event, which happens to a cloud provider. So I mentioned health checks. Another example graphic that we pretty much have set up is here you can say you've got two systems. The first one saying, are you there? The server responds. The next one is there, and it doesn't respond. So it gets marked as unhealthy, and it gets removed from the rotation. So whether you're using AWS Route 53 or you're using any DNS system, there's going to be a lot of logging and monitoring capabilities that you can use, especially if it's an industrial grade system. Route 53 enables logging of your DNS queries, things like capturing the domains or subdomains that requested it, the date and time of the request. So you get to see who went to and actually requested information or performed the DNS query. With AWS, you will get action logs in CloudTrail. And CloudTrail, which we'll talk about later, is for auditing, where CloudWatch is for monitoring. We'll talk about that later, but you can kind of understand that. It will monitor domain registration. The Route 53 dashboard will give you insights into domain registration status, including information on, say, domain transfers and when your domains will expire so you can renew them on time. And you can set up your health checks. Here's an example of what a health check might look like. You could basically query the Go Cloud Careers website, and you can see that all servers will be healthy. For example, if we're using AWS Route 53. So you can monitor the Route 53 resolver endpoints with CloudWatch, and you see what's going on, the volume of the DNS queries being processed. And that'll give you some insights into your traffic. And you can see, you can get some information that's pretty interesting. You'll be able to look at certain features and really see what's going on with your systems. Okay, well, now we're going to get into one of my favorite topics, which are load balancers. And no, network architects don't normally work with load balancers. I love load balancers. And the reason I love load balancers is they enhance performance and they enhance availability. And anytime you have something that can make systems work better and be more available when the users need them, now you're talking some stuff that's exciting to me as someone that comes from a heavy infrastructure background. So let's talk about what a load balancer is. In the normal world, a load balancer is a physical device that will distribute your network on application traffic. And in a data center, you call F5 and you're going to get some big, robust load balancers, and they're going to be there. In the cloud, it's a software-based service that actually to distribute traffic among different systems. Load balancers are awesome because they can help with scalability. So imagine this. I've got one server with 64 cores and a terabyte of DRAM, and it's not enough. I've got two options. I can change that server to a 128 core server with 2 terabytes of DRAM, and now I've solved my performance problem to a point. But what happens when the server crashes? I've got nothing. And, once I get above an actual 256 physical cores in today's world and say 6 terabytes of DRAM, I'm out. I'm done. There's nothing else I could do. What happens if you're Google? What happens if you're Amazon and you get millions and millions and millions of requests? Not a single server can do it. Enter the load balancer. So what the load balancer does is enables us to add more servers. 10 servers, 20 servers, hundreds of servers, thousands of servers. And if you're going to deal with a company like Google, they may have 1 million servers out there for doing their web stuff, or more, actually, probably a lot more. So if you think about that, and a lot of that sharing the load gets done with load balancers. But it's better. Let's say I've got 5 servers underneath the load balancer. The load balancer determines one of the servers is dead. It's okay. It distributes traffic to the other 4. And in the cloud, we can add another one on demand with auto scaling. And that way, it improves our availability. So load balancers are good stuff. So when we talk about load balancers, they're going to come from, realistically speaking, 2 categories: network load balancers and application load balancers. Network load balancer is going to operate at layer 4, that OSI model that we talked about. So it's going to be the IP address, the protocol, the port number. source and destination. That's it. So 192.168.1.1 wants to talk to 1.2.3.4. Port 443. And I just made up the 1.2.3.4. I don't mean to be using a public address. Probably should have, for example. So that's what a network load balancer does. Now, is only looking at the TCP or UDP, the protocol source and destination address and port numbers. That's not a lot. So network load balancers are fast. So you want a load balance between huge servers, you need a network load balancer. Want a load balance between firewalls or network devices, you use a network load balancer. Well, there's a gateway load balancer, which is very similar to a network load balancer, but that's the concept of what these things are. They're big and bad. But it's like anything else. If I asked you to do 2 plus 2, you could do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. It's nothing. That's why network load balancers are fast. Now, what if I asked you to calculate a derivative in your head? Could you do that at the same speed that you could do 2 plus 2? Or any kind of advanced calculus you want, or advanced statistical metrics? That's going to take some time. It's okay. You got to think about it. You got to slow. It's a bigger workload. So the application load balancer is smarter than the network load balancer. But it's like asking it to do calculus versus simple addition. So it's going to be slow. So there are times when we use an application load balancer. When a load balance between microservices, it's perfect. Want to look deep into, say, somebody wants to go to a web server and you want to look inside of the header and the HTTP, whether it's push, get, that kind of thing, application load balancer. So application load balancer, super smart, but not fast. Network load balancer, super slow or super fast, but not as smart. And there's times where you're going to need to combine these load balancers to get speed and intelligence at the same time. But that's way beyond the AWS Solutions Architect Professional. And we'll never be able to finish this course if we talk about it. That's the kind of stuff we teach our architects. So when we talk about AWS's load balancers, they had to make up their own funny name. So to them, it's Elastic Load Balancer. If you want to be able to communicate with your clients, it's either going to be a network load balancer or an application load balancer, because they understand that, and that'll be the same terminology you can use in every cloud provider. You don't need to call it a cloud load balancer with Google or an Azure load balancer. Call it what it is. Your clients will understand you and they will thank you. For the test, remember the silly marketing name. So Elastic Load Balancer is kind of auto scale. They use an IP address. So make sure you've got enough IP addresses. They can load balance across availability zones, which means data centers. Load balancers support health checks. So, and they can also terminate SSL connections. And let's talk about that. So if you want to hit a web server and you're using HTTPS, that's encryption. And encryption is incredibly computationally expensive. What do I mean by that? It uses a lot of CPU resources. So if your web servers have to terminate the HTTPS, their capacity to work will be much less. The fact that an AWS load balancer, most load balancers, can actually do the HTTPS encryption and terminate those connection requests means they can offload a lot of the work that your web servers do to these load balancers, which means your web servers can also scale much greater. So load balancers are awesome. So when we deal with load balancers, there's a couple of terminologies you need to know about. The first one is called the target. What's a target? The target is where the load balancer distributes the traffic. So it could be an EC2 instance or a virtual machine. The target could be an IP address. But if the target's going to be an IP address, it's going to have to be either a private address, as specified in RFC 1918, or it's going to have to be in the shared address space environment. And that's the 100.64.0.0/10. You can see that in RFC 6958. All you have to do is Google ietf.org, RFC 6598. You'll get that whole specification. If you want to read the private IP addressing scheme that was designed by the Internet Engineering Task Force, like all CCIEs do, go to the ietf.org and look up RFC 1918. But RFC 19 private address spaces are the 10.0.0.0/8, the 172.16.0.0/12, and the 192.168.0.0/16. You can also see that on our AWS Advanced Networking, our subnetting workshops that we do, which are free. My team will provide links for that. And even a CCNA free course, which we have on our channel to help you with networking knowledge. So we talked about a target. Now, what if you wanted to route it to a group of servers instead? Well, AWS enables you to create something called a target group. So send the traffic to the group Cindy the Cat's Toys, and then every one of those servers in Cindy the Cat's Toys gets the share of information. Now, when you deal with a network load balancer, because a network load balancer looks at the TCP source and destination and the protocol and port number, if we've got a user, say Sally hits server 1, Sally is going to be on server 1 for her entire duration. Now Billy Bob comes in and he gets naturally sent to server 2, and Billy Bob will stay on server 2 the entire time. Now Costandinos gets sent to server 3 and he will stay on server 3 the entire time. And that's often called the sticky session. And the way network load balancers work, that always happens. Now, if we're using an application load balancer instead, the application load balancer will route each request to the server with the lowest load. So might send it to server 1 the first time, server 2 the second time. Remember, these application load balancers are smart. So if you need some sort of session persistence and you need to make user 1 stay on server 1 the entire time, you can do that. And it's called the sticky session. And the way these load balancers will do that is they'll use a cookie. They'll put a cookie in the browser to track the connection, and that way they send it to the same server. So different ways to achieve the same things. So whenever we're using a load balancer, we need a health check. Because if we want to share the load between 50 servers, but 2 of the servers are dead, that means two out of 50 times the traffic is just going to be dropped. And those users aren't going to be happy. And we want everybody to be happy, right? So we got to make sure our systems work. So the way that's going to work is with a health check. I know I did it under DNS, but perhaps somebody wasn't here when we covered it this morning. So I'll draw it out one more time and I'll show you the way it could be in a load balancer environment. So we might have a load balancer here. Let's say we've got big bad servers. Let's say these servers have a couple of terabytes of DRAM in them, and say 256 physical cores. So we could have a VM1, VM2, VM3. Let's have VM4 too. I'll give you a containerized example too, because it really doesn't make a difference. And what's going to happen is the load balancer will say, hey, server VM1, are you there? And it's going to say, woohoo, I'm here. I'm having a good time, having a party, serving up content. VM2, are you there? Yeah, I'm here, serving a party, having fun over here. VM3, you there? Yep, I'm here. President accounted for, all's good. VM4, are you there? Now, this happens for a period of time. And then the load balancer says a health check. Server 1, are you there? Yeah, I'm here. Server 2, are you here? No response. Server 3, are you here? Yep, I'm here. Server 4, are you here? Yep, I'm here. Runs the next query. Virtual machine 1, are you there? Yeah, web server 1, I am happy. Virtual machine 1, virtual machine 2, web server 2, are you there? Nope, no response. Virtual machine 3, are you there? Yep, virtual machine 4, I'm here. Happens a few times. And then the load balancer says, this virtual machine 2, not in existence. Let's mark it out and only send traffic to virtual machine 1, 2, and 3. Now, this is really no different than if this was an application load balancer and this was a container. Container C1, C2, C3, and of course you could use a network load balancer too. But containers usually have less resources. You probably use an application load balancer in most cases, and the load balancer would share traffic amongst the containers. It's no big deal. It's the same thing. It's a lot like DNS. Did I share that on the screen, hopefully? So I hope that makes sense. So if it pops up on your exam, AWS has something called the classic load balancer. And it can either be a network-based load balancer or an application-based load balancer. It's a legacy platform, and AWS doesn't typically, what's the word I'm looking for? They don't typically recommend it, but it has all the features and functionalities for the most part of any other load balancer. I don't think I shared my screen when I was trying to show these load balancers and health checks. And if that's the case, I'm sorry. So I'm going to do it again. So let's go back into this environment. Two different very simple architectures for load balancers. Virtual machine-based load balancer and a containerized load balancer. So you'll have maybe a network load balancer with these virtual machines because they all have, say, 256 physical cores and what do you call it? Let's say 4 terabytes of DRAM, and they're running on bare metal. So server 1, are you there? I'm here. Server 2, are you there? Yep, I'm here. Server 3, are you here? Yep, I'm here. Server 4, no response. Server 1, are you here? Yeah. Server 2, are you here? Yes. Server 3, yes, I'm here. Server 4, no response. That happens 3 or 4 times, and then the web server, the load balancer says, web server 4 is not here, so only use server 1, server 2, and server 3 for our traffic, and it'll keep running it. Same thing. We could have a microservices-based application running in a bunch of Kubernetes containers, and Docker containers, for example, where it's orchestrated, say, by Kubernetes, that kind of thing, or whatever we want. And the application load balancer will send to the first container, the second container, the third container, the first, second, third. They will also run a health check. Container 1, are you happy? Yes, I'm happy. Container 2, are you happy? Yes, I'm happy. Container 3, are you happy? And your function, are you there? Yes, I'm definitely here. All's working well. Server 1, are you there? Container 1, yes, I'm here. Server 2, no response. Server 3, yes, I'm here. Server 1 to the health check, are you there? Yep. Server 2, no response. Server 3, yes, I'm here. Container gets marked as unhealthy, and the container no longer gets traffic. And then the load balancer distributes traffic between container 1 and container 2. So now, when we talk about the AWS network load balancer, understand it's not a physical device. It's a logical device, so it shouldn't go down in most cases. And we can use it to multiple targets. They could be virtual machines like EC2 instances. They could be containers, or they could be IP addresses. These things are fast because they're network load balancers. So think millions of requests per second and very low latency. We can also use it. So keep that in the back of your mind. High performance. Now, some of the things we can do with AWS network load balancers, which are kind of cool, is we can put a static IP address on it. And we have to, and here's why. So you've got your virtual machine, right? And that's going to be the place where your virtual machines are at behind the load balancer. We put a public IP address on the load balancer. That's what we put in DNS. DNS is a record that points to the IP address of the load balancer. And behind that load balancer, your website is going to be sitting on, say, containers or virtual machines. So keep that in the back of your mind. It supports a public IP address or more. Obviously, it's going to have to if it's going to be an interfacing load balancer. And it typically preserves the client's source IP address. And that's going to be necessary in there's certain cases if you need to see the backend application needs to see the source IP address of the client. There might be reasons for security and other you might want to do that. Load balancers provide what's called zonal isolation, and they're designed for high availability and fault tolerances by supporting multiple availability zones. And they run health checks like I showed you, like all load balancers do. Most good load balancers, along with the AWS load balancers, will terminate a TLS connection. Like I said, offloading that HTTPS off of the, the web servers themselves will enable them to scale. And it's also integrated with private link network load balancers. So they support enabling private access to certain services that might be hosted on AWS. And you can even load balance across availability zones. Now, whenever we deal with load balancers, there's a couple of terms. There's typically something called a listener. And the listener is the process on the load balancer that's going to be looking at connection requests. It's going to be looking for that. And the target group, or the target, is where those requests are sent. It could be a virtual machine. It could be an IP address. It could be a function as a service like a Lambda function. And then each target group will specify a protocol and port number where the traffic is going to be routed. So with our load balancers, we can set up rules. And the rules will define how the incoming connections are going to be routed to the target groups. And of course, no load balancer would be worth anything without a health check. So how do we set these things up? What's necessary? Well, you create a load balancer. You can go to the Amazon management console and look up and select load balancers. You create a load balancer. Now, if it's a network load balancer, you're going to click choose network load balancer. Then you're going to name the load balancer, Cindy the Cat's load balancer. And you're going to determine, do you want it to be internal, meaning inside of your private internet stuff, private IP addresses behind it, or external or internet facing. You'll configure it as internet facing. That means it's going to be out to the internet. You'll pick an IP address type, IPv4, IPv6, or both. And you'll add a listener. You'll configure your availability zones that you want to use. Or you potentially can pick an IP address for the load balancer in the selected availability zone. You configure your target groups, which is where you send it. Again, it could be a virtual machine, an IP address, a function as a service like a Lambda function. And then you register your targets. You review it, and you click create, and everything's done. It's pretty simple stuff. So you have the ability to put protection on your load balancer like a security group. So that enables you to provide a little bit of protection. Up until about 6 months ago, it wasn't supported on Amazon. Couldn't figure out why, because it's a basic function, but they now allow security groups on other load balancers. You can also apply an IAM policy to control access to the load balancer and its resources as well. An identity and access management is really determining who you are, determining what you're allowed to do, and then keeping track of what you've done. And we'll talk about that much more. So our load balancer will connect to Amazon CloudWatch for monitoring. And you can also connect it to AWS Cloud Shell for logging, say, API calls and requests for auditing purposes later. And very cool with these load balancer, along with most, is they will terminate TLS connections for security. That was the network load balancer. So let's talk about the application load balancer now. The application load balancer is a layer 7 of the OSI model load balancer. And this is designed for advanced routing needs, such as path-based routing. And it's going to integrate with various AWS services. So, the way these are going to typically work is you're going to have a load balancer, and they're going to have listeners, and they're going to have rules. And that's how they know where to send your traffic. And they'll all run health checks like we talked about earlier. We talked about how those health checks work. So application load balancers are smart. So let's talk about the features of the AWS application load balancer. It provides content-based routing, meaning you can route your traffic based upon the content that's being requested, whether it's host-based, path-based, or HTTP header-based. They support WebSockets, things like HTTP/2 support. By supporting WebSockets for full duplex communication, it provides some improved performance. Just like the network load balancers, they will terminate SSL connections, which means offload that worked from the container or the web servers, which makes them scale better. They support advanced request routing, and that's supporting routing rules based upon, say, HTTP headers or methods or query string parameters and the source IP address. So again, these are smart. They're doing a lot. It can work with the AWS certificate manner for your SSL or TLS-based certificates. It can integrate WAF, as a AWS proprietary firewall that you could use. Although in an enterprise environment, you'll most likely be using next generation firewalls, because not only can they block things, they can look for patterns of anomalies and stop attacks in their tracks. So they're very advanced. People that make next generation firewalls that are used in enterprise security are companies like Cisco, Palo Alto Networks, Fortinet, Checkpoint. There's a few others as well. F5 makes them. And you will get these from the AWS Marketplace, and they are the kind that you could use on AWS, Azure, and Google or OpenStack all at the same time and in your data center and have the same systems. And they typically provide very robust protection, more than you would get from, say, a cloud native firewall. But these things you can also support one. And there's nothing to keep you from using a next generation firewall and an AWS WAF in your solution as well. Application load balancer, the AWS ones, support sticky sessions or that session affinity. We talked about it with regards to a cookie. And they support target groups, and you can route traffic to multiple target groups, containers, virtual machines, IP addresses, Lambda functions, what have you. Application load balancers can integrate with auto scaling, and it will adjust the number of, say, virtual machines or EC2 instances you will need based upon the load on these systems. And they integrate with logging and monitoring. And quite frankly, when you're dealing with a cloud provider, unless you want to go to a load balancing system like from an F5 for, say, a reverse proxy, you're going to want to use these. And even if you go into a more robust load balancer or a reverse proxy from something like F5, you're still going to need the Amazon load balancers to load balance because they'll be in virtual machines. And by nature, virtual machines aren't high availability devices. These AWS application load balancers will have that same listener function like we talked about and the same target group that we're talking about. So you'll define rules, and the rules you define will determine your routing. Path, host, headers, some kind of query parameter. So how do you create the application load balancer? You create it. So you go to the load balancer section, you click create, Cindy the cat's ALB. And will you set the scheme, internet facing. Listeners, or let's say the cat's web servers are on port 443 because she's going to sell tuna and other cat goods. You never see what my cat does with her paws on my PC. It's kind of scary. And then you'd select your availability zones. Then you set up your security settings. So maybe you put a security group on the load balancer. Maybe you put a certificate, and you can get a certificate from anywhere. But you could use the AWS certificate manager to get a certificate, or other companies like GoDaddy, etc. And then we need to configure our target groups. Okay, so let's take a break, answer some questions, and then we'll get back to the content after we answer some questions. Let me fill my water here because I've been talking a lot. Can you set up DNS on 2 cloud providers so we don't have a single point of failure? Well, you have to have a robust DNS solution. So if you choose an industrial grade DNS solution, the kind we've been working with for 30 years, and you would normally have your DNS server, say, in 10 different data centers for an organization that has it, you've got DNS. You take those same servers, stick it in every cloud provider that you have, you've got a robust DNS solution that will work no matter what, and you won't have a single point of failure. Because you own it. That's going to be different than trying to manage and integrate Amazon's DNS into Microsoft. It's not very challenging to manage DNS. Why do you see Cloudflare being the fastest, faster than AWS CloudFront? So here's the reality. There's no such thing as the fastest. It might be the fastest where you're at. So everybody's going to go say, I have the newest, I have the best, and it's a bunch of marketing fluff. All businesses that matter use more than one content delivery network. If you go to NS Lookup right now and do an NS Lookup, some of you will find that Amazon's using Fastly. Some of them will find that they're using CloudFront. Some of you that are finding they're using Akamai. So they're all good. And it's your mileage may vary. But, to go out there and say that Cloudflare is the fastest, I don't think that's a reasonable thing to say. I can show you times where it's the fastest. I can show you times where it's the slowest. I can tell you times where AWS is the fastest. I can show you times where it doesn't matter. So the key is not having a single point of failure in your content delivery networks. In the AWS Solutions Architect Associate, they'll say use CloudFront. But even Amazon themselves wouldn't just use CloudFront. They'll use multiple content delivery networks. So the real key is don't use more than one don't use a single, a single content delivery network. If you do, you're going to find yourself in trouble. Can an application work balancer work without a target group? It's got to route to something, typically a target. I don't really configure them because I'm an architect, but so I'm not 100% sure. Part of my architecture as an architect would be, okay, here's where we need our application load balancers. Here's where we need our network load balancers. Here's where we need to use both to get speed and performance. And let's figure out where those are going. But the actual configuration, that would be something a cloud engineer would do. And it's just not something I have experience with. But should you put a load balancer before or after the firewall? You might have to do both. So in a cloud, in a data center, I can put two firewalls directly together and they run a heartbeat between them. But they're physical devices. In a cloud, actually with AWS, I think with Palo Alto, you don't need a load balancer, but if you're using somebody else's, you will. So I might need a network load balancer to load balance between my firewalls. I might have a second set of firewalls where I'll need another network load balancer for my firewalls. I might then need another network load balancer in front of two IDS, IPS systems. And then I will have another load balancer behind my firewalls where the web servers are. But you might have an application load balancer inside of your network because they're an internal application that you won't have firewalled off. So it really depends on what you're trying to do in your architecture. And I've given you a whole bunch of different options. And you may need a combination of all of them or none of them based upon the client you're dealing with and what their goals are. But generally speaking, put your load balancers behind the firewalls. Do you need a elastic IP or public IP address if your system placed in the firewall? It depends what you're trying to achieve. So if you've got a firewall in front and then you've got a demilitarized zone and the load balancer is public, then that load balancer will definitely need a public IP address on it. But by comparison, if it's a load balancer inside of your internet, and maybe you've got 20 HR servers, for example, well, that traffic isn't going to go through the internet. That traffic is going to go through your wide area network, which, like we talked about yesterday, direct connections or VPNs, for example, that you could use. And then you would not put a public IP address on that. So kind of think about that. It depends where it's placed and it depends on what your goals are. So, Ref, I think you're actually asking the wrong question. So the question is not how a bank would use a load balancer versus how Netflix would use a load balancer. And I get where that's actually coming from. But here's what you need to be concerned with. What is the organization's business goal? What is the organization's business processes that they need to have? And what is the technology that drives that organization into improved business performance? That defines my architecture. The tech doesn't drive the architecture. The business needs, workflows, and business processes drive the architecture. So you're going to have to start by that first. So that's the key. So I might have a bank, for example, that's creating a super high performance compute environment that has a critical low latency application that's an internal application where they may have 50 servers with 256 cores and 8 terabytes of DRAM each and NVMe rated arrays in them to be super fast to create a low latency something. Low latency auto trading system, for example. By comparison, they may also have a website, and they're going to use a load balancer across their publicly facing websites. They may also have an application that needs incredible high performance and intelligence. So they may place some network load balancers in front of application load balancers and load balance between the application load balancers, and then say have microservices behind them, if that's the way their application is. But what matters is not the technology. What matters is what problem are we trying to solve, and then we do it. The same way where a physician has to interview the patient, determine what their medical challenge is, make a diagnosis and a plan, we're doing the same thing in architecture. What is that client's business goal? How does that business operate? What's normal for them? What's abnormal? What is that business pain points? We have to make a diagnosis and then build a plan called the architecture. So I can have two banks that are going to use the technology completely differently. So if we learn from, for example, what others have done, we're ultimately going to be learning how to solve someone else's problem. We have to learn at the problem at hand. What is the problem we're trying to achieve? How does that organization operate? And that's when we train cloud architects or enterprise architects. The role is 50 to 75% business. And it's not covered in the certification because, and I'm giving you far more than the certification has here. The certification is kind of a name of a service and how to configure it. Architecture to make the design answers that you're actually asking the question is examining the organization, understanding where they want to be 3 months from now, 6 months from now, 9 months from now, a year from now, 5 years from now, 20 years from now. Examining the way that business operates, the business processes, like how is a product made? How does the supply chain operate? How is a service delivered? How is it supported, etc. And then determining, is that the way we want it to be, or is that not the way we want it to be? If it's not the way we want it to be, it's working with that organization to find their strategy and helping them craft those new processes. And then evaluating the technology they have. Is the technology going to get them there? And if not, what technology changes do we need to support those goals? And only then can we even think about the architecture. I hope that makes sense. So what defines if you need a network load balancer or application load balancer is the size of the destination. So the choice of a network load balancer or application load balancer is defined by the type of traffic you have and the required features that you need. If you have high performance systems, big systems are huge systems, you're going to want, and you need high performance, you're going to use a network load balancer. Got servers with 256 cores. These are big servers that demand big performance. And you're not going to want to slow it down with an application load balancer. But what if we've got, and there's lots of applications out there and lots of things businesses use. But if we've got an HTTP or HTTPS website, or we're going to be dealing with WebSockets, now we need intelligence. So that's when we're going to use an application load balancer. So we need to kind of understand the goals. Chris, we go to the next one. Will a load balancer work with Global Accelerator? Sure, it will. We can use a load balancer with Global Accelerator, and we'll talk about Global Accelerator later. But Global Accelerator basically gives you a static anycast address that's going to route your traffic to the optimal endpoint. But yeah, we could load balance that kind of stuff too. What kind of a load balancer do you need with auto scaling groups? Any of them will work with auto scaling groups. So application load balancer, network load balancer. And when do you use the network load balancer? So network load balancer, high performance, low latency. Application load balancer, we need smarts. Routing in between, say, microservices, looking at the content of an HTTP request, WebSockets, that sort of thing. All right, so in keeping with our theme, let's get back to the content. But I need to know you're awake. So a couple things. I want to tell you about. If you haven't gotten the book on which certifications are going to be good for your career as a cloud architect, that kind of thing, please get the certifications guide. It's completely free. And actually, I'm going to have my team pop a link to how to become a cloud architect or solutions architect. It's a free ebook we wrote, because a lot of these questions I'm actually getting are so good, especially some of the questions by Ahref and a few others. But they're putting the cart before the horse. And that's okay. We all start there. We all get excited about the tech, and we have to figure out the business components later. But in order to work, we need to get the business. So if you download that completely free e-guide on how to become a cloud architect, it'll talk about everything that we need to learn and those skills. And it's a free ebook anyway, so why not get it? So do that. If you're having a good time, please like the video. Please hit the subscribe button and the bell to be notified of new things that we've got to help you in your career. And I'll get back to the content now, but not without a hashtag. I need to know you're awake, alert, and oriented. So give me a hashtag SAA-C03. So Sierra Alpha dash Charlie 03. For those of you that like to use the phonetic alphabet. Maybe you were an airplane pilot or a firefighter or something like that. So now let's talk about gateway load balancers. We're on load balancers. I like load balancers. So gateway load balancer is a network load balancer that is used for the directing traffic to virtual network appliances or security appliances. So if you need robust security, you're not going to be using your cloud provider's firewall. You're going to be getting an industrial next generation firewall from a security vendor. It's a time where you would use a gateway load balancer, for example. And a gateway load balancer kind of feels like a bump in the wire. We're going to do, say, some inspection where a set of firewalls we can service multiple VPCs. And this opens up a lot of opportunities for security as a service. And what it's going to typically look like is as follows. You may have your load balancer here, and you may have people that are coming back and forth. And what you can see is this load balancer creates this little tunnel between this gateway load balancer and your appliance. It uses something called AWS calls a Genevieve encapsulation. For any of you that are used to GRE tunnels, that generic routing and encapsulation method, where basically you tunnel something across an IP network, that's what we're really talking about. So you'll have your sources that are the target before the load balancer, and that'll go all the way back to whatever's behind the scenes. Hope that makes sense. So how does a gateway load balancer work? Well, a lot like a network load balancer. But the gateway load balancer is going to be an endpoint that's going to be consumed by your hosts, load balancers, virtual machines, what have you. And it's going to force traffic to be sent towards the gateway load balancer. So it's going to create that private tunnel between where you're at and the security appliance. And it's going to encapsulate all the traffic to the security appliance. When the security appliance receives the traffic, it's going to decapsulate it, meaning get rid of those tunnel headers, inspect the traffic, and then re-encapsulate it and send it back to the gateway load balancer subnet. And again, it uses that Genevieve encapsulation. And it works with many of the security providers you would deal with. So when it comes to an industrial grade, high performance, high security environment, you're typically going to be dealing with the main security companies, and you use like a gateway load balancer for this. Most companies would be Cisco, Palo Alto Networks, Fortinet, etc. And it enables you traffic inspection to kind of see what's going on. So let's look at what you could see it looking like as another approach. You can see you've got your applications, and they would be behind this load balancer endpoint. And you might even send it all to, say, an inspection VPC to be looking at all the traffic as it's going in and out of the internet. And you can see you've got your VPC that's going to have traffic inspection. You can see you may have an inspection VPC where everything goes. So companies need to know sometimes for security and compliance reasons where their traffic's going. And these gateway load balancers really help a lot with it. So think about this. Inspection of your outgoing traffic from your VPC to the internet. It's going to give you a lot of information about your traffic and the type of traffic and what's going on. And, find malicious traffic as well. The security appliance will receive that encapsulated traffic, decapsulate it, inspect it. And when it's done, it'll send the traffic to the load balancer. So when would you use the gateway load balancer? If you need efficient traffic management, meaning seamless traffic and scaling of network traffic, and you need high performance and consistent latency across multiple virtual appliances like firewalls, this is your go-to load balancer. If you need enhanced security and inspection, and who doesn't in today's world, the gateway load balancer helps you work with big security providers and their services to improve your security. If you want to add some high availability or fault tolerance, you need a load balancer, right? And the gateway load balancer will help with that as well. And it can be relatively cost effective and simplifies your infrastructure. And it's going to help reduce your infrastructure costs by optimizing the resources that you're using and cleaning up your network architecture and making maintenance and updates a little easier. So there's that. Now, I did talk about sticky sessions before, but maybe we talk about it a little more. So I mentioned with network load balancers, your traffic goes directly to the same end server each time. But with application load balancers, they go each time to the server with the lowest latency. But if you don't want that to happen, you use a cookie, and the cookie will enable the server to come in. So Cindy the cat goes to tuna.com, for example, and they have an application load balancer. So they put a cookie in her browser, and that way Cindy ends up on server 1 when she's trying to buy her tuna. So that's realistically what's going on. So keep that in the back of your mind. And that way you can be stuck on a single server. Now, why would you care? Some servers require state and you to be attached to that same server, and they can't go through all the other servers in the application. So if it matters, you're going to use sticky sessions, and it's basically just a cookie. And you can see what it looks like here. Without sticky sessions, users keep going all over the place. With a sticky session, they're given a cookie, and they stay on the same server each time. So sticky sessions rely on an application cookie at the HTTP or HTTPS headers. The client cookies can either be maintained in web and generated by the web application itself, like an application-based cookies, or they can be maintained and generated by the application load balancer. That's called the duration-based cookie. Application-based cookies allow the load balancer to take advantage of the already existing session cookies. And using these cookies, an application load balancer pins the client session to the same target throughout the entire session. Duration-based cookies are used in the case where the web application doesn't natively support a web cookie. And in this case, the load balancer will pass the cookie to the client and maintain that sticky session. So when you should use sticky sessions, you may want to enhance the user experience, because sticky sessions are going to ensure a smooth, uninterrupted user experience. And it's being really crucial for stateful interactions like shopping carts. It'll improve your efficiency. By consistently routing user requests to the same servers, a sticky session will optimize resource utilization, and that's going to enhance your application performance and scalability. It can also increase your security and your reliability. Because a sticky session provides encrypted stable connections, it's going to be crucial for secure error-free transactions. So let's talk about load balancers. Internal load balancers versus external load balancers. All right, so what do I mean by this? I'm going to draw this out because this is where a lot of people get confused on the difference between intranet and extranet. So this is the way a normal environment looks. let's say this is your secure data center. Now, this could be a physical building. It could be your VPC. It really doesn't matter. This is a secure data center. None of this is part of what I'm doing now as part of the AWS Solutions Architect Associate, but it's critical architecture knowledge. What do you want to allow in this secure data center? Absolutely nothing. No traffic from the outside world should be allowed in here unless you have to. And let's say this is going to be one subnet. Let's say this is an HR application. You don't want that exposed to the internet. And this could be a finance application. Ugh. This could be a finance application. There's going to be lots of applications that an organization have. If we have 5 HR servers, we'll just argue a couple over here. You know what we're going to need to load balance in between these servers internally? A load balancer. So we might have a load balancer in front of these things. Bear with me. Load balancer. This stuff is internal to our VPC. Same thing we'd have, let's say we only need one finance server. Out here, we're going to have some kind of a firewall type architecture. And this is not what it would look like. We'd need a lot of layers. But this is a firewall type architecture that we might have. Behind the firewall, we might have a network load balancer. Well, it wouldn't go behind the firewall. The firewall would be here, and the firewall will block all incoming traffic. So all incoming traffic is blocked at the firewall. Now we might take the firewall and create a subnet off of the firewall and pop a load balancer over here. Say a network load balancer, it doesn't matter. And then behind the load balancer, we might have some web servers. Web. So when you look at this, there should be no traffic that comes into here. Nothing should be coming in. So this load balancer is an internal load balancer because it's inside your organization. Now, we also have this firewall, which protects everything here. The firewall has a subnet, and the firewall says this subnet allows TCP port 443. Why TCP port 443? Because that's HTTPS traffic. So this is only going to allow 443 to DMZ load balancer. And that's all it's going to allow. So the firewall will allow port 443 traffic to this load balancer. The firewall will block everything coming into the systems. So this is an internet-facing load balancer. This is an internal load balancer. Okay, well, the next thing we're going to talk about is CloudFront, which is a rather lengthy topic. So, Chris, let's see if anybody has any questions right now. None yet? Okay, then we will cover CloudFront. Now, I might want to get all of you involved while we do CloudFront. In fact, I want to do it right now, and I want you to enter the information inside of your system. So I want all of you to open up a command prompt. On Windows, you type CMD. On a Mac, you open a terminal. On a Linux system, you open a terminal. And I want you to put the answer in the chat box. I want you to type up NSLOOKUP, NSLOOKUP, www.amazon.com. And I'm going to see if I can find a way to share my screen here. Because let me see if I can do this. Okay. Okay, can everybody see my window right now? Go to a command prompt and type NSLOOKUP, www.amazon.com. Press enter. And I got this. If you do this on a Mac or a Linux machine, it's going to give you the actual CloudFront of Amazon.com. I'm using a Windows machine, and I've never used a Windows machine in my entire life. But if you will actually use your Linux or your Mac, or you type NS lookup www.amazon.com, at the bottom of it, you're going to get something that looks very funny. And that's going to let you know whether you're on CloudFront, whether you're on Akamai, or whether you're on actually, say, Fastly. So share in the chat box what you actually got, or NS lookup www.amazon.com. Tell me which content delivery network you actually have. Are you going to see Fastly? Are you going to see CloudFront? Or are you going to see Akamai? Let me know in the chat box what you're saying. And I know there's some latency between what I'm saying and you're saying. So I'm curious to see what you have to say in the chat box of what you're finding. You see Frontier, Adrian. Okay. Some of you others will see this as well. You see CloudFront. You see CloudFront. You see CloudFront as well. And interesting, I can share you mine now. Apparently, in order to get to do anything fancy in Windows, you've got to go to Windows PowerShell versus just the command prompt. So I'll share with you what I have. And there's a reason I want you to see this. Chris, hold on one second. Let me share. And if you don't know what to do, let me show you what to look at. You can see, if you look up Amazon.com, you can see my DNS providers, which are Google. They're giving me this. This is the ugly name. And then this is the name. And what you're going to see is there'll be a CNAME record. And for example, you're also going to see this. This is Frontier. So why are you seeing some users on CloudFront and other users on Frontier? Why would you see this? Tell me in the chat box why not everybody that Amazon using is on CloudFront. And some of us are on CloudFront. Some of us will be on Fastly. Some of us are on Frontier. Some people may be on Akamai. So why? And keep sharing it in the chat box. Why is it that Amazon is using more than one cloud content delivery network? See Fastly. You're seeing lots of them. And here's the reason why. Because a single cloud is a single point of failure. A single content delivery network is a single point of failure. And the cloud provider themselves is not going to only use their own content delivery network. And, that's the difference between certification and a reality. In certification, they're only going to teach you the one. But when it matters in real business, they're going to be using multiple content delivery networks. So it's not who's got the best technology. It's what's the right technology for the business, and how do we design these things for redundancy and scalability? That's what matters. So keep that in the back of your mind as we go through things. We try to give you the overall example of how businesses would do it for real, not just what would be done in, say, a certification. So now let's talk about CloudFront. CloudFront is the Amazon branded and Amazon owned content delivery network. And a content delivery network is a geographically distributed set of servers that's going to provide fast access to your internet content. Organizations use content delivery networks to reduce bandwidth costs, to reduce the load on their servers, to reduce the latency, and protect themselves from distributed denial of service attacks. So let's talk about content delivery networks. They can really help protect against a distributed denial of service attack. And we'll talk about how that works as well, because they won't send, and we'll talk about it more later, but they won't send illegitimate stuff to the servers. And we'll talk about DDoS and how it protects. They also can promote enhanced availability. And here's why. Let's say I've got a web server for a static website. The user actually requested the information. The information is cached on a CloudFront server. Now the website goes down for 5 minutes, but somebody requested the same website that was already in the cache. The cache answers, so it's there. So I kind of hope that makes sense. So CloudFront or any content delivery network will improve website hosting performance. And CloudFront is a combination of a network, a high-performance network that connects you to caching servers. So it's not just the servers. All those caching servers are completely worthless without a network behind them because they wouldn't be able to reach each other. So it's a network and caching servers. And the way it's going to work is when a request is made, the location will be determined, and it will be sent to the closest CloudFront server or content delivery network server. And those servers will cache the content, and we'll walk you through examples. So the first request is going to get sent to the CloudFront caching server. If the caching server has it, it's called the cache hit. And the content delivery network will send it right back to the user, and life's good. CloudFront's a great content delivery network. I don't want you to think it isn't. It's a wonderful content delivery network, but if it's high availability, you're going to need more than one content delivery network. So if you hit the, say, CloudFront content delivery network, and your web information isn't stored on the content delivery network, the information will go to the source. The source will answer it, and the content delivery network will cache it for the next time. So that's the way this is going to work. So here's a situation that I'd love to show you. We've got a client, right? The client is going to a website. It's a static website that's hosted on an S3 bucket, an object storage bucket in AWS. Sends the request to CloudFront. CloudFront doesn't have it. It's called the cache miss. CloudFront sends the request to the S3 bucket. S3 bucket answers, sends the asset to CloudFront. Now another user on the bottom wants to go to get that website or that image or whatever it is, and CloudFront responds. So that's how it enhances scalability. That is a major help. Because let's say we got 1 million requests for the same page. Web server only responds once. Content delivery network does the rest of the responses. So CloudFront is a content delivery network. So it provides caching and website scalability. Caching can really offload something. I want you guys to imagine this. My wife, for some reason, has been wanting to go see Taylor Swift and watches Taylor Swift videos on YouTube all the time. Apparently, I know how popular Taylor Swift is. If Taylor Swift got a new cat and then tweeted the cat and posted the cat on Instagram and every other media channel in the world, imagine the web server that's going to host that photo of Taylor Swift's cat. Can get millions of requests globally for this cat, literally speaking, in minutes. But she tweets it. It goes on a server that gets requested. The content delivery network caches that information. And after the request from each content delivery network location, they all get to see photos of Taylor Swift's cache without the website responding. Think about how much that can help with scalability. So if we're talking about CloudFront, it's going to integrate with numerous AWS services because you could have a website on S3 for static content. You could have dynamic content on virtual machines, say EC2 instances. You could actually want to use CloudFront in front end various load balancers, that kind of thing. And CloudFront is constantly used for web services because that's what it's designed for. So This is a common environment for a web server environment where you're going to have dynamic content that's going to be hosted on virtual machines, otherwise known as EC2 instances, and you'll have a load balancer in front of them. And you might have static content like videos or cat photos or whatever our product photos are sitting in an object storage bucket or S3. And that's how the systems will be cached. The source of it is considered an origin. So let's talk about some key concepts with CloudFront. There are three main components to understand. And they're going to constantly show up on an AWS exam. It's going to be the distribution, the origin, and cache control. We'll first talk about CloudFront distribution. When you set up CloudFront, you'll set up a distribution. Your distribution is going to be that weird looking ugly name that we talked about over there that you could actually see. So let me do this. I want to make it clear to you what this actually looks like, and then we'll talk about what we actually talked about today. So Chris, please share the Windows PowerShell right now for me. You see this ugly looking address over here where it's the two addresses you might see, that kind of thing? That's ugly looking, right? But that is going to be the CloudFront distribution name. So think about that. Who's going to remember this name? And who can remember this? Delta 3 Alpha Golf 4 Hotel Uniform Kilo 62 Yankee November.cloudfront.net. I'm not going to remember that, but I can remember www.amazon.com, and I go buy cat treats from them all the time. So, kind of think about that in the back of your mind. So if you don't want this and you want something pretty, was there a type of a record that we talked about when we talked about DNS? Yes, there is. It's going to be called the CNAME record. So what you can see is, or an alias record, you can map www.amazon.com to another one of these ugly content delivery network distribution names for Frontier. So hope that helped there. So that's what you'll fix. You'll create a CNAME record or an alias record to make something pretty to the CloudFront information, to the CloudFront distribution. Now you also have to set up a CloudFront origin. What's the origin? The origin is where the source of your content's coming from an S3 or an object storage bucket, an EC2 instance or a virtual machine, or an elastic load balancer, meaning a load balancer or your website. And mind you, I will constantly try to go through the real terminology plus the AWS terminology, because if you understand the real technology, you'll know what to do on Azure, Google, Alibaba's cloud, Oracle's cloud, or what have you, because you'll understand the tech. And it's all pretty much the same. So when you're dealing with a cache, and a content delivery network has caching, you have to think about the control and the cache and your architectural options. So by default, CloudFront will cache data for 24 hours. Now this means if your system is cached at one of those edge locations on a server, and you change your website, somebody might not see your website for a whole 24 hours. Now, if your website doesn't change very often, and it changes once every 3 months, and nobody notices it and a new change for 24 hours, who cares? By having the cache at 24 hours, your web servers don't have to do a lot of work, because those caching servers remain brand, and your web servers can be sleeping or napping half of the time. But if we change the cache to a small period of time, and we change the website 20 times a day, the users will see new changes, which is great. But every time that cache expires, all those new requests are going to have to go to the new server, and that means the servers are going to be much busier, working a lot harder. So it's the architectural trade-off. Do I want to reduce the load on my servers and use less servers? Okay, I can increase the TTL. If I have changed my thing frequently, I'm going to have to increase the load on my servers by decreasing the TTL, but my web page will be seen with every change we make. So hope that kind of makes sense to you all. So how does somebody set up a CloudFront? They set up web servers and they put content on them. Then they create their CloudFront distribution. AWS will give you that ugly name that I showed you. And then you either accept the ugly name or you create like an alias record or a CNAME record, and then AWS will provision your edge locations, and then you're going to have a good solution here. So if you'll recall, on the first day when we talked about AWS and how it's organized, we talked about a region being this large geographic area. And we talked about data centers being called data centers in this region, and data centers are called availability zones. I didn't make up, these are all marketing terms. And we talk about specific data centers, which are typically internet point of presences called edge locations. And that's where, that's exactly where your information is housed. So walk through another example of this with CloudFront. Let's say we've got 3 different edge locations in different major cities. In edge location 1, one of the users wanted to read, an article that I was in CIO magazine. And they went to our website, www.gocloudcareers, and they looked at some of the places that I've been in, places like Tech Republic and Tech Radar and DevOps Magazine and Data Center Magazine and Information Week and other magazines. So lots of people, maybe they went to our website to see it, which articles I wrote for which magazines. So user 1 goes to www.gocloudcareers.com, and they hit that edge location, and user 1 is over here. It gets sent to our cloud hosted systems, and it gets sent back to the edge location and back to the user. The next time somebody wants to go see that article from the same edge location, they go straight to the edge location, and the edge location sends it back. So it really can reduce the load, but that's not going to help the user sitting in Athens, Greece. So the user in Athens, Greece hits the cache and says, I want to see, Mike's articles. I wonder if Mike read any articles in Greek. And while I speak Greek, I don't really write magazine articles in Greece. Not that I wouldn't. So the user in Athens goes to www.gocloudcareers.com, and it's not there. So it hits the local edge location and say Athens. And then it's going to hit the regional cache. Then it's going to go back to the source. The information is sent here, and it's over there. And then right after, let's say Nico in Greece went to the edge location, Nico texted his buddies, Aguilo, Costa, and a few other people. And then when Aguilo and Costa decide to hit that edge location and say Athens, Greece, they get sent the information without the web server. So that's kind of how these systems work. So understand that CloudFront or any content delivery network can have a massive impact on your website performance. Content is cached. Now, CloudFront has over 217 points of presence for these caching servers. That's pretty awesome. Pretty much most major cities in the world. And when CloudFront is used, what will happen is the request will go to the original source through the AWS backbone as opposed of necessarily the internet, so better connections. And CloudFront can have what's called persistent connections, and it'll maintain connections with the source. So, there's not going to be a need to start a new session every single time for every new web request. So it's a great content delivery network like many others. Now, on this content delivery network, like all content delivery networks, you can put a WAF firewall, a web application firewall, and some form of a DDoS protection. Amazon has their DDoS protection called Shield. Every other one has their own DDoS protection as well. But CloudFront can really do wonders to protect against DDoS attacks or any content delivery network, and that's one of the reasons organizations use it. How does a content delivery network help prevent a distributed denial of service attack? So here's what a distributed denial of service attack. We have how the hacker infects, say, 100 computers on the internet. And then he tends those 100 computers to go send as many requests as they can to you, to send more requests than you could potentially handle. That's a distributed denial of service attack. So let's say my web servers can handle 10,000 requests per second. And how the hacker sends 1 million requests per second. My web servers can't respond to legitimate traffic, and they're dead. They're just overburdened. Now, if I had auto scaling, perhaps we can add 10,000 new servers to deal with this hacking event until HAL infects another 100 servers sending requests. But that's neither here nor there. And that can help us mitigate it, but that's going to get real effective, although we could use it in terms of an emergency. But here's where content delivery networks like CloudFront come to the rescue. If Hal the hacker is sending invalid, illegitimate web requests to the server, which is very commonly done, the content delivery network's kind of smart. Let's look at those web requests. They don't belong. Let's just block them. And then the servers don't get overwhelmed. So it's one of the many things that content delivery networks do very well. Plus, CloudFront can provide encryption in transit of your data. CloudFront can enforce your SSL or your TLS protocols. CloudFront will integrate with the AWS certificate manager, so you can use certificates generated by AWS, because there's lots of certificate managers out there, or certificate authorities out there. And CloudFront, like most content delivery networks, will support server name identification and custom certificates. So you can also use CloudFront for private content. So lots of times you would be using CloudFront to serve a public website or an internet-facing website. But what if you only wanted to restrict access to a certain number of individuals? Maybe you've got a private application only for paying members or subscribers. You can do a couple of different things to allow certain people to access it. When you set up the origin access identity, which is where the stuff is coming from and let's say you have an S3 or an object storage bucket that actually is providing the website, you can restrict the S3 bucket to certain key individuals. So that way people that paid for your system can access it. You can also send a signed URL or a signed cookie to restrict access to a public content delivery network. So I kind of hope that helps. You can also do georestriction on a content delivery network. So what might that be? Georestriction is also known as geo-blocking, is a feature of the AWS Content Delivery Network, and others do the same, that enforces delivery of your web content to clients in specific geographic regions. So why might you do this? It enables you to serve your content to people that are interested in your information and deny clients from uninterested environments. Now, let's say you provided a service that was not considered acceptable in certain parts of the world. You might want to geo-restrict those certain parts of the world so they don't blame you for your service or fine you or something like that. So every country has their own what's appropriate, what's not appropriate. I'm not here to judge the world. I take everything in context. Culture determines everything. But geo-description or just blocking may keep you from getting legally in trouble if your content is accessed in the wrong parts of the world. So what's an example of this? So here's an example. You let someone access the information because they're allowed. Maybe someone in this particular case from Egypt wants to go to a server in France and they're allowed. Or maybe in this particular case, you don't want a user coming from Egypt to a web server in France and you can block it. Egypt's a beautiful place. I don't know if you've ever been there. Had lots of times there. It's really, really great. But this is just a particular example of different countries with different laws that may or may not allow certain things. So just an option to think about. And it's just a country picked at random. So how does georestriction work? Well, what happens is there's a database of IP addresses that are associated with each region and country. And for example, if you were to whitelist only Germany and a user from the United States tried to access it and only Germans were allowed in German websites and people from the country of Germany were allowed, they'd be blocked. And by default, when you're going to get a user that's denied access, CloudFront will give you one of the 400 codes and it'll say 403, which typically means forbidden. Geolisting either works via whitelisting or blacklisting countries. Whitelisting means allow, blacklisting means block or deny. And it can be implemented to deny access to only specific content or certain subfiles because certain things could be allowed and not allowed based upon where you're going. So in order to implement georestriction, you will need to use some form of a third-party restriction service and integrate them into CloudFront. So you may remember proxy servers where there was a service that would say you can't go access this, but it was a specific company that proxy servers would connect to. Same kind of thing. So why would you use georestriction? Legal compliance. And make sure that your content is going to adhere to legal rules. And also licensing agreements maybe as well. Security enhancements. If certain people are never going to buy your stuff, and you know that, why would you not only reduce the load on your server, but allow yourself to be seen by those that aren't going to buy your stuff or access your content or need your content or use your services? Because when it comes to security, use the principle of least privilege. Don't give access to something if they don't need it. So that's going to be from a security posture perspective. Content localization as well. Oh, that's another one. Deliver region-specific content for better audience relevance. Let's say you're in the Middle East. There's a lot of languages that are spoken, okay? And I spent lots of good time over there. Some countries speak Farsi. Other countries speak Arabic. Other countries speak other languages. But I got to tell you, if I go to a website and I can't understand it, it's going to be hard for me to be comfortable. But if I get the one that I can read, that's another thing. So that's another reason you might want to use georestriction. So that actually brings us to about 5 p.m. So let me open it up for questions. See how you're doing. Are you all having fun? I know I'm having fun. I love teaching. And let's see if you have any questions. How do you determine the cost of CloudFront compared to other services? You call all these cloud providers, you negotiate with them, you negotiate with all your other CDN providers, and then you determine the costs. Just like anything else. You go to 3 car dealerships to figure out who's going to give you the best price on the car. And when it comes to dealing with multiple service providers, well, this service provider is giving me this, and what are you willing to do? So I hope that helps. Pick up your phone and call the sales reps. Thank you so much, Adrian, to say great class. I'm super happy to hear this. Any other questions? Having fun? Mark, that's really great to hear. Let's see. I'm having lots of fun, Mark. I love doing these sort of things. Okay, well, let me tell you about a couple of things in case you just joined us that are free that I would love you to get access to. For the next 2 weeks, we will be talking about technology for 2 weeks straight. It's what I love. And then after that, our team will do some hands-on tutoring. We'll put out a subscription link to that when it occurs, so you guys can sign up for that as well. But I also want you to know that we've got 40 plus labs for you to follow along with. So go sign up and get them. My team will provide the link to that. And my team is also going to give you the link on how to become a cloud architect. That there's a document to it. There's also webinars we run. So if your goal is to be a cloud architect, there's a free link that I'd love you guys to join. And Arif, I know you asked some really good questions, and I really want to answer them because they're very good questions, but they were career questions. So, please join us for one of our free webinars, and I look forward to meeting you there. Mark Trimble, good, consistent content and topic. Mark Trimble, if you want to know somebody that's a super technical, expert on technology. He's one of those. It's a phenomenal architect, knows so much about tech. I don't know about you, but tired, lots of information process, and need to see how much results you retain. So I understand that. Yeah, we're going through a tremendous amount of content. I'm giving you 3 to 5 times more what would be in a solutions architect certification, because I want to be able to give you good information. So go out there. If you have to watch it 2-3 times, that's okay. Ben, you are more than welcome. Mark, thanks. Great class, Mark. I'm always happy when you're here. Cantor Grant, thank you so much, Mike and team. Great boot camp. I'm so happy to hear that, Cantor. Really appreciate you, Mark. I know you, and I'm thrilled to know you personally as well. Anna, it's a great class. Thank you so much. Okay, so I'm so thrilled that you're all here. And if you haven't liked the video, please give it a like. And subscribe to the channel, hit the bell to be notified, and we will see you tomorrow. To close out, please give me a hashtag. AWS. Give me a hashtag AWS. There's 100 of you. Maybe I get 107. That way I know that everybody is here. So tomorrow, we have some more fun networking things. People were already asking about Global Accelerator and other things, which we'll talk about. They'll be there. And we will have lots of fun. We have, lots of content to go through. So love all these AWS. Go share with a friend too. Let them know that this is going to be completely free. We just want to share our knowledge. I love all these AWSs coming in, and these AWS Solutions Architect Associates. And again, this is free AWS certification training for the Solution Architect Associate, SAA-CO3, but we're covering way more than that in this program.